What's up, my guys? Thanks for jumping on the stream nice and early. I see all of you there waiting. They've got like, what is it? Something like 28 people waiting. Wow. How's it going, guys? Glad to see you enjoying the repair live streams. Got some interesting stuff here this evening. This is going to be pretty cool, I think. Now, got a couple of amps here. I'll just wait for the kind of stream to pick up a little bit, but I'll just go through what I'm looking at. So I've got a couple of amps here that have come through from a really good friend, older tech from the UK, and he's kind of doing less repair work now, more sort of R&D stuff. Really knowledgeable guy, so not worth wasting time on repairs and stuff like this most of the time. But got a couple of amps through from him, and because anything that's easy to repair generally will bang out nice and quick, but anything a bit more in depth is like, I ain't got time for this. So usually the amps I get from this guy are interesting, in depth, maybe got a little bit more complicated faults. So I thought it'd be a really cool idea to jump on stream with a couple of these, and thought it might make for some good content, because the last few streams I've done, I've just kind of been plagued with this thing where I'll think, oh yeah, I'll do a stream this evening. I've got this amp, this amp, this amp, and this amp to look at, and like 3 out of 4 of them will either work absolutely fine, like the customer must have had an issue with their wiring or something like that, or it'll be just a really simple fault that's just really quick and kind of boring to do on stream. So hopefully we should see some interesting faults on this one. I've already taken a small quick look at the first amp we're going to be looking at, and it's going to be a bit more involved than just replacing some outputs, so should be interesting. Rockford Power Series. Don't get a great deal of this stuff in. Naturally, the stuff that I see the most, the stuff that I'm the most experienced in, is the stuff that dies the most. It's the shitty, the unreliable, generic Chinese kind of circuits and Korean and stuff like that, and the new Chinese full bridge stuff that Sundown and Ground Zero Def Once are bringing out. So I see a lot of that stuff because it dies a lot. But stuff like okay, I need to change my hotkey settings. So I did a live stream the other day where I was doing some music production, and I've changed the hotkeys on my pedals to be for that. So let me just quickly change them back. OBS key 14, 15. Anyway, like I was saying, what the heck was I saying? Rockford Power Series. I've got 2 4-channels. These are the T1000 and T800. 4-channel, they are Class D, or Rockford calls it Class AD, I think they call it. It's basically Class D, but it's marketing. So okay, let me get rid of OBS key 15 and 14, and on pedal number 2 I want the top down board. Where's that one? Board top down, there we go. I want that one, and then this last one I want hat cam, which is going to be not there, here. Hat cam, switch to scene, key 15. So that should now be working. Yep, there we go, and there's the old spicy hat cam. Okay. Yeah, cool. Shift this over a bit. So this is the first one we're going to look at. This is the T1000, and inside she looks like this. Can do a zoom in, see what it looks like. So the beauty of working on multi-channel amplifiers like this is that if you have a fault with one channel but the other channels seem to be okay, then you're kind of in a bit of a blessing, because the channels are going to be just mirror images of each other. They're just going to be clones of each other almost. So if you've got an issue with one channel but the other channels seem fine, then you can use the channels that are fine to find what's wrong with the one that's not working. You can compare voltages, you can compare resistances, diode mode readings, you can compare the channels that are working with the one that's not to help you find what's wrong with the one that's not. And in this case, with this being a Class D, we actually have upright drive cards here. See these 4 bad boys here? So these are the drive circuits for each of the channels, and they're pretty complicated looking boards. You got a complete sea of components on that side and a complete sea of components on that side. So this is why I thought this would be an interesting one to repair, because I think this one's got drive circuit issues, but we're not going to have the same issues on all 4 channels. We're going to have at least one channel out of the 4 that is working fine, and so if need be we can actually just literally swap these driver cards around with each other to confirm, is the problem on the board or is the problem on the driver card. So yeah, that's one of the cool things about working on multi-channel amplifiers, and the same goes as well. Even mono amplifiers, you'll often find that they actually contain, rather than a mono amplifier being just one output section, one output circuit, it'll actually be 2 or even 4 output sections or channels, if you like, that are then paralleled together into one channel. A bit like bridging, a bit like strapping, but it's done in parallel on the board. You'll find that if you look inside any mono amplifier, the number of inductors that you see on the output section generally is the number of individual amp sections that you've got. So on some of the bigger Korean amplifiers, you'll see there are 4 inductors. There's actually 4 separate little amplifiers there on the same PCB that all parallel together to do the power into 1 ohm. Let's have a quick look at some live chat. How's it going, guys? Thanks for jumping on the stream. Sam makes it a great day when you be live streaming. Thanks, man. I appreciate that. I skipped streamers. Bro, I was busy as heck in December. There was no chance of doing streamers this year. I will consider it for future years, but it's a lot. I could maybe do like an hour a night instead, but it was a lot when I did it that first year. I did streamers. It was like 4-hour streams every night. It was wild. But lucky I had enough work to do at that time. From Ecuador, how's it going, my man? Hopefully not too bad out there. Ended up missing the BP Rebase live stream. Sorry about that. What song did you have working on? Well, it was kind of a bit of a... It was a bit of a... It didn't really go too well. So, let's not talk about that. Hi from Romania. What's up? From Philippines. What's going on? Wow, people from all over the world interested in some Rockford Fosgate repair, North Dakota. What's up, my man? That's what I've been trying to do with my Orion HCC 4000.4. Yeah, for sure, it's useful, provided the amp's not in protect fully. You know, provided that the other channels are up and running, then you can use that to figure out what's going on with the thing. Finish the rebase. Now it was boring, man. It was a pretty boring stream, and people weren't that keen on it. So I think we'll skip that. All right, should we get started then? Let's take a look at what we've got going on here. So, like I said, Rockford Fosgate T1000-4, I think it is. What I'm going to do first of all is, I have already confirmed, is the first thing you should always do, is there any shorted FETs? So there's no shorted power supply FETs, power supply is absolutely fine, and you can kind of do a quick confirm on that by just taking your multimeter probes and going between 12 volt and ground and making sure that there's no continuous beeping or continuous short there. As you can see, we're just charging capacitors on the multimeter, so the power supply section is fine. Output section, we have 1, 2, 3, 4. So each channel is comprised of just a pair of MOSFETs, one high side MOSFET and one low side MOSFET, which is pretty cool because you won't run into issues with MOSFETs running in parallel and not being well matched. You could essentially just throw whatever FETs you liked in each of these because there's just one FET. They're not running in parallel with each other, so there's not really going to be any issues with different VT or different RDS and stuff like that causing problems in parallel. So we don't actually have any shorted output FETs. So if we just take our multimeter here, we've got a multimeter on diode mode setting, okay, which is cool for measuring MOSFETs. It gives you a rough idea. So if we take, I think this is the high side. On the high side between gate and source, we have a 589. Let's do that. That's on this channel. Go over to this channel. We have a 589. This channel over here, we have a 589, and this channel we have a 589. So we've got continuously the same numbers across these 4 channels, which would say that that's fine. That area, you know, the thing there that we're looking at is fine because it's the same across all 4 channels. If we look at this one here, I think this is the low side. We have 976. So let's go for this low side over here. We're charging a cap. Okay, so this is where it's starting to look a little different. So on this low side over here, we're reading 976 between gate and source. This channel over here, we're reading 571 over here, 573, and this one over here, a 572. So I already know that this is the bad channel anyway. We can show that by powering it up and seeing what it's doing. But using a multimeter on diode setting and measuring between gate and source is a good way, because when you do that, you're not actually reading the MOSFET, okay? If you take a MOSFET like this here, and you read between gate and source, you're not actually usually going to get anything unless you get the MOSFET turned on first. See that? I get absolutely nothing on the multimeter screen. Maybe do it that way as well. I don't think I get anything. Yeah, nothing. So reading between gate and source, you're not actually reading the FET. By doing this on the amp, we're actually reading the driver. We're actually reading the drive circuit here. So that's a good way to kind of see what's going on with the drive circuit. Are the drive circuits all reading the same value between these channels? And if they're not, then that can tell you, oh, there's probably a drive circuit fault. And we know already that the drive circuit issue is on the low side, because the high side one's all matched up with the other channels, the low side one didn't. Anyway, let's get some power wires hooked up in here, and we can then turn it on and show you what it's doing, because we've not got any shorted FETs, so we don't need to worry about that. Screw that in up here. Hello from Morocco. Wow, how's it going? How is it in Morocco anyway? Actually, funny, I watched a video today. Some guy in the UK travelled all the way from London to, crap, what was it? Somewhere in Africa. He went through Morocco into Marrakesh, somewhere else, all by train. So it was like a long ass journey. There was no talking. He was just literally just documenting the travel. Through there into Morocco and Marrakesh. Seemed pretty cool. It was interesting seeing obviously the scenery change from being in the UK, lots of kind of city and then countryside, and then going through France, lots of vineyards, and then going through Spain, lots of olive trees, and just like a much different kind of landscape. The land was a very different colour, a lot drier, and then obviously coming out of Spain and going in through Morocco, you just get desert, literally desert, and like a random tree, like just like someone's like dragged it in from the pool and just like slapped the tree in there. I'll tell you what, let's actually put up on the screen, let's put up the current amp we're working on. I'll try and stay on top of it this evening. I usually forget to stay on top of it, so we're working on a Rockford T1000, what is it, dot 4 dash 4 AD, they call it the AD, even though it's just Class D. Although it looks like this is a bespoke circuit, so that's one of the cool things that I like about Rockford. Let me just go through and enable all of that on the other screens. Current, that's a bit big. Oh, what's going on? So that's one of the cool things. I do have respect for Rockford in that regard. Rockford Fosgate, they are expensive, but they do design the circuits absolutely from scratch. So what you see here is Class D 4-channel amplifier, but so they call it the Class AD. It is just a Class D, but it's their own design. They have done some proper long R&D and design work on this to make it perform a certain way, to make it maybe nicer sounding than other Class D4 ranges, or give it better control over the driver, or less floor noise, better channel separation, stuff like that. So I do have respect for brands like this that do just put the extra time in and put the extra money in to employ engineers to design stuff from scratch. You know, design their own bespoke circuit. You buy a Rockford Fosgate amplifier, you're getting a Rockford Fosgate amplifier. You're not getting some generic circuit that you can find cheaper in another brand. Although the Rockford Prime, not necessarily all of their lines, like the Rockford Prime, they are generic circuits some of the time. But with the kind of higher end stuff, this is not like anything you'll see from any other manufacturer or brand. So pretty cool. Yeah, do have respect for them for that. So now we have power wires going in. Let's get the scope turned on and we can see what this is doing. Gonna just shove about 10.3 volts in there. Don't need anything too high just for now to show you what it's doing. And about 5 amps, let's go down to about 4 amps, 3.8 amps. Limit it to 3.8 amps. Zoom in a bit on the scope. Okay, so if I just pulse the remote from it, we can get a little bit of rail voltage built on here. So, like I said, we've got, these are the output MOSFETs, because this is a Class D full range. So we got a high side and a low side. So on the high side, we should expect to see the positive rail coming in, as we do there. You can see that on the scope screen as I pulse the remote. Positive rail is coming there on the high side, and on the low side, we shouldn't have anything at the moment, because that's where our PWM will be once it starts oscillating. But we should have negative rail on gate and the source of the low side. legs 1 and legs 3. See that there? Leg 1 and 3 of low side has negative rail, and positive rail is on leg 2 of the high side. That's cool. So the problematic channel appears to be over here on this side. So let's just check that we don't have any voltage leaking anywhere. So high side, yeah, we've got positive rail. Low side, we have got negative rail on 1 and 3, nothing on 2. So what I'm going to do is I'm going to hold my oscilloscope probe on the drain of the low side, and we should see PWM appearing here when the amplifier fires up. Oh, we don't get PWM. What do we get? We get negative rail. So look at that. Oh, if I turn my buttons on, I can show you the scope screen. AD to key, LP8D start, yeah, and that one. So if you can see on the scope screen here, when I probe the low side drain, and then if it comes on, we just get a swing to negative rail. So we've got full DC, negative DC on the speaker terminal. And that's all over here on the speaker terminal as well. Yeah. So for some reason, the second we apply the remote, instead of oscillating, instead of building a self-oscillating environment and switching this MOSFET, we have just DC on the MOSFET. And this is kind of interesting. This shows that there's a drive circuit fault, but it also shows that it's potentially not going to be too bad. When there's a drive circuit fault, you can have two things. You can have either this issue here where you've got the low side and the high side, and they're going to turn on and off in an alternating fashion, okay? And the worst kind of fault you get is where both high side and low side are told to turn on at the same time, because then the voltages just combine. There's a direct link to positive rail and negative rail, and they just cancel each other out, short out, and you usually get a lot of damage, pop, bang, smoke, etc. This kind of drive circuit fault, what we've got is we've got the low side. We've got the low side being told to turn on and staying on, but the high side isn't being told to turn on. That's how it should be. The drive circuit, when it's kind of functioning, it should be like a seesaw. You should have one and then the other, one and then the other. If you've got both, you'll get an explosion, or you get shorting and excessive current draw. If you get just one, you get DC offset. So we've got negative DC on the speaker terminal, which means that the low side FET is being told to turn on and stay on. And we can confirm that by taking our oscilloscope probe and probing the gate, which is the the kind of signal switch, if you like, that's going to be telling this MOSFET to turn on or off. As we turn the amplifier on, give you the scope screen, you can see negative rail starts to build, and then so that's negative rail right there. So this right here is negative rail. As soon as I hit the remote, you see how it bumps up. So we've got down, bumps up, down, bumps up. So this bumping up right here, boop, this is the MOSFET being told to turn on and stay on. And that's now off, on, off. How's the stream looking for you guys? I just realised I got a bunch of dropped frames then. It was kbps, we're right down to 500 kbps. Hopefully it's not buffering or anything for you. Let me know if you get any issues with the stream, guys. I'll check the live chat in a minute. I'm just on a bit of a roll at the minute. So that's what's happening with the problematic channel. The good channel, we can confirm that this is just an issue isolated to this channel by probing the low side drain of the other channels. So we've got these three channels up here, which seem to be fine. If we turn the amplifier on, probe the low side drain, you can see there that we have, eventually when the amp comes on, we did have earlier when I gave it a quick test. Come on, you can do it. Maybe it needs a bit more voltage, 12 volts. There we go. So this is what it should look like. This is one of the good channels that's currently working fine. We have rail-to-rail switching on the low side drain. And same on that channel, and same on that channel. So we've got channels 1, 2, 3 here working absolutely fine. Channel 4 is just giving us negative rail DC. So there's a drive circuit fault there that we need to investigate. And on the gate of the low side, you can see there that we should have these little pulses. This is what's telling the MOSFET to turn on, off, like that, in little pulses. And obviously on this one down here, we don't have that. We just literally have negative rail. We just have a continuously on signal. This is just a continuously on signal there. So yeah, we need to dive in, find out what's going on with the drive circuit there. It should be an interesting one. Now, how would you tackle something like this? So the first thing that I would probably do is I would start tracing back from the MOSFET gate. So like I said, the thing that's going to be telling that MOSFET to turn on and off is going to be on the gate of the MOSFET leg. So leg number 1, this is the leg that should have the little pulses on it, the little square waves that tells the FET to turn on and off. So what I'll do is I'll take my multimeter and I'll start tracing back. Where does that originate from? It obviously goes through somewhere through the board, and it's probably going to be going to this driver board right here. So I want to see what is the final component that connects to this leg. Is it a transistor? Is it an IC, an integrated chip? Is there a resistor in line with it? And then I'm going to start testing components, working my way back from the gate leg, and you know, until I can see or I can find a shorted component or a resistor that's out of tolerance or open, or a shorted diode or something like that. Let's have a look at what's going on the stream. Wow, my dude, Paul, thank you very much for the 10. Holy crap. Unbelievable. 2 consecutive days of stream. Wait, was it yesterday that I streamed? No. Was it yesterday? I don't think I was yesterday. I thought it was the day before yesterday, but either way, thanks very much for the 10, my man. Did you run out of booze? No, I'm good. I'm stocked up. What's your opinion on ripping CDs for quality reasons compared to streaming? Yeah, I would definitely recommend that. CDs are, I want to say lossless, but CDs are still encoded in a kind of, you know, they're still converted to digital and then have to be converted back to analog again. So to say they're entirely lossless would be a little bit false, but the bit rate and the you know, the actual data rate of the music on a CD is very high. So you're not, on an average system, you're not really going to notice any difference between CD and anything better than CD, like any file type, you know, any FLAC or something that was technically better, higher resolution than a CD, unless you got some absolutely stonking SQML winning competition system, then you're sitting in a dead quiet car park in the middle of the night with an engine off, and you know, you're really switching between the two. You're probably not going to hear any difference. So I think CD, yeah, for sure. Although with streaming these days, especially with Tidal and stuff like that, you got high quality streaming, lossless streaming, they call it. It's not really, but again, you're not really going to notice the difference between CD and maybe Tidal's highest tier streaming option. And a vehicle is the worst acoustic environment for critical listening anyway. The acoustics are horrendous, your listening position is way off, you got to get a stereo image by time aligning everything, and also while you're driving, obviously you got engine noise, road noise, traffic. It's the worst environment, so don't worry too much, but definitely you will notice difference between CD and Spotify, for example. I definitely notice a huge difference between the two, even just in the van, which isn't set up for SQ as such. So I've seen a Rockford Fosgate so bad that not even you, Bevids, could repair it. It had a literal burned hole through the circuit board. I've seen some amps like that for sure. I haven't seen any Rockfords like that. But usually the area of the board that gets a hole burned through it is either the power supply section, which is very easy to repair. Power supply sections are heckin' easy. You just rebuild the traces that are dead, or like where the rail caps are, or something like that. And yeah, you could probably repair it. Like. Your one screen is black. I think that might be my scope. The day before yesterday was the last stream. Yeah, I was going to say, I didn't think it was yesterday. Hello Hassam, I've got several Rockford amps I'm hoping to get back up and running myself. Good stuff, man. Yeah, Rockfords can be a bit of a pain in the butt because they are bespoke amplifier circuit designs and they're not generic. You build up less experience with them because you're less used to working on them, because you know, most other amplifiers will be a generic circuit design that you can really get used to because you're repairing them a lot. But yeah, Rockfords, they are bespoke circuit designs, so you don't necessarily build as much experience with them as you otherwise might with other brands. Right, so let's get this out of the case then, shall we, and start having a look, working our way back to the drive circuit to find our problem. So I'm just going to take the power wires out for a minute, get rid of this front beauty plate, the plastic always snaps on, and the board. I have already unscrewed it, so it just comes out like this, which is very nice. Okay, so what do we need to look at then? This channel over here. Like I said, we want to trace back from the low side gate and see what is the last component before the MOSFET. We should have a gate resistor. There'll be a resistor before the MOSFET for like dampening purposes and to prevent ringing and stuff. So if we actually looks like we might actually have a little transistor right by the FET, which might actually alleviate the need for a gate resistor entirely. Let's zoom right in there and let's have a look. Now I'm going to try and get the board angled up slightly so you can see a little easier. So I believe that there might be a little transistor just here that is like the final buffer, the final drive buffer, and being so close to the MOSFET, that might even alleviate the need for a gate resistor. There is a resistor right here, and can I read the value on that? That is a 10 ohm resistor, which is kind of gate resistor style values. So let's just give that a quick read, shall we? Make sure that we are reading 10 ohms. It's on diode mode, so it shows 16. So yeah, we have 10 ohms exactly, so that resistor is fine. Now, is that on the gate? Is that connected to the gate? Yes, it is. So we have gate, 10 ohm resistor. 10 ohm resistor goes through to somewhere other than this transistor. So this transistor also connects directly to the MOSFET gate. And what I think might be going on here is you might actually have the drive wave from the drive circuit, so the actual pulses come from the drive circuit through the gate resistor into the MOSFET gate, but then this transistor is going to be like a pull down transistor, so it's going to be also receiving the drive wave from the drive circuit. If I can get my probe, this capacitor is very inconveniently in the way. I might actually have to just remove that from the board so I can get in under there, because I want to probe this top pin of the transistor. I can't actually get to it with this cap in the way. So we should have that may be connected to, so this transistor may be a pull down resistor transistor. It may also be a diode. You get diodes that are in this package with the 3 legs, but they actually only have like 1 anode and 1 cathode. We can check that by seeing whether these 2 legs are these 2 pins are connected, which they don't seem to be. So I don't think this is a diode. I think this is actually a transistor. Now, what does this transistor read on the multimeter? We have nothing this way round. And nothing this way round. That can be normal. The readings might come through from the second pin up here, the top one, and I can't actually get to it. So what I'm going to do is I'm going to go ahead and just take this capacitor off the board real quick so we can get better access to potentially some components underneath here. That might be the best thing to do. Actually, what is it labelled as? I can actually see there's a label under there. It might even be a diode, actually. That might be why we're not getting any reading through legs 1 and 3. One of those legs might actually be not connected. There is a marking in the board there. I think it's a D, which would mean that this would be a diode. D7. D... yeah, that looks like D7. And how about the one on the other FET? Because obviously these are all going to be the same. So if we look at another channel, we can see what the other channel has, and it will be the same. So if we look at this one here, we've got a low side and a high side, and yeah, it looks like it is actually a diode. So okay, that's going to be, that diode is going to basically most likely bypass the gate resistor. Perhaps that's one thing that I've seen done lots of times in amplifiers, especially with higher switching frequencies and high gate charge MOSFETs, is you'll have a diode in parallel with the gate resistor, so that when the drive comes from the drive circuit, it has to go through the gate resistor to the MOSFET, which dampens it, prevents ringing. But then when the drive tells MOSFET to turn off and pulls the current back the other way, it can actually go through the diode. The diode is set up to allow the current to travel backwards from the FET to the drive circuit, so that the turn off pulse doesn't have to go through the resistor, because you don't want that. You want the turn off pulse to pull the current away from the FET as quickly as possible, to turn it off instantly. So you'll have a diode in parallel with the gate resistor to allow the current to flow through the diode quicker than it would do the resistor on the off, but then block it on the way up. So that's what it might be. I do actually have a schematic for this board which I can dig out, but I actually kind of like working without a schematic, you know, because I feel like I learned the circuit a bit better as well. I'll only turn to schematic at the last moment if I need component values that are burnt off that I can't find elsewhere, or if I'm really struggling to find, you know, to trace where a component is connected to, etc. So okay, so we've got a diode there. That's unlikely to be, this diode here is unlikely to be the reason that we've got no pulses on the low side gate, and it's just telling it to turn on continuously. That's unlikely to be the reason. Even if it was failed, it wouldn't cause that. It would cause other problems. So we want to find out then, what is this gate leg connected to? So I'm going to flip the board over, because I believe the drive circuit for this channel is probably going to be this one right here, this driver card. So if I flip the board over, oh, we actually have probably the final drive on the underside of the board. I hadn't actually looked on the back of the PCB yet because I hadn't taken it out of the case, but looks like we have the final drive for this channel on the back of the PCB. So these driver cards will be doing the PWM conversion. So these will be generating the PWM, the pulses for the output section, perhaps doing some clever kind of control circuitry or some protection circuitry stuff, because we have right here, we have a MOSFET driver, we have an IRS, let's have a look. I want to try not to cover up the camera with my head. We have, get some thermal paste on this so it's easier to read. That's a little trick. If you can't read the component because it's too hard to read, then just wipe some thermal paste on it and it suddenly becomes way easier to read. IRS 20, what? Oh, what the fuck? I haven't seen these before. IRS 20124S. That's a new one. I hope it's not proprietary to Rockford. I doubt it. I don't think they've got that kind of buying power. That's the sort of thing you see from Alpines. You'll see drivers, output drive ICs that are proprietary to Alpine, and you can't fucking buy them anywhere. Right, so let's have a Google then. What exactly is that? Have not seen one of those before. It's going to be very similar to stuff that we've seen before. IRS 20124S. 20124S. What does that look like? And what are the pinouts? Obsolete. Love to see it. You love to see it. You love to see an obsolete part. Let's check out the datasheet. See what we've got going on there. Now, we don't know if this is the problem, but I'm just really curious to see. Oh, what the heck? To see what the datasheet looks like. I want to see what kind of driver it is. 200 volt, high voltage, ratings deliver up to 1000 watts, output power into Class D, audio amplifier applications. Cool. Give me the datasheet, yo. Oh, I freaking hate these websites. They give you the PDF, but it's like embedded in their site. Just give me the... Download it, and then open it. There we go. That's what I want to see. Digital audio driver with discrete DAD-DP. Okay, so we have single inputs rather than high and low inputs. So yeah, it's just going to be taking the single PWM. That's not going to be split into high and low input before the chip. It can do that internally. We have dead time and shutdown pin combined. So that will be, okay, I see. So the dead time and shutdown pin. So it will go from being lowest amount of dead time at one extreme, and then as you increase the voltage or decrease the voltage on it, you'll go higher and higher dead time, more and more dead time, until you get to a threshold which it will actually just turn off, and there'll be 100% dead time, if you like. OC overcurrent, perhaps it's got protection built in, maybe. I'm just kind of guessing what these mean at the moment until we scroll down, just kind of having a bit of fun. COM is ground, low side output is going to be this pin here, 1, 2, 3, 4, 5, 6, 7. Pin 7 is low output to the MOSFET, which you can see here. High output is going to be all the way over here. VCC, that's going to be the chip's power, not connected on pin 9. VS is going to be the feedback from the low side drain before the inductor, so it knows what it's doing to build the safe oscillating environment. High side output. VB, this is going to be the bootstrapped supply for the high side to oscillate on, and then a couple of not connected pins. Nice. So let's see what is the things that it's saying about this. OC input voltage from these are the absolute maximum ratings. Let's have a quick look at the regular and recommended operating. So 0 to VCC. These are going to all be 0 to VCC because these are like logic level signals. Low side output voltage. OC set. So the floating high side voltage could be 200 volts. Wow, these chips could be used in some pretty big amplifiers. Like, what's it saying? 1000 watts RMS. 200. Oh, I see. Because like when they're not expecting you to build a 1 ohm stable amplifier, they're expecting like 4 ohms for like professional applications and home theatre and stuff. So yeah, you'd need like 200 volts worth of rail to get. I'm just guessing probably 1000 watts into 4 ohm, for example. Okay, cool. Does it give us a definition of the pins though? Ah, yeah, here we go. Yep, VB, VSB, DT and SD. Input for programmable dead time. Yep, reference to COM. Shutdown LO and HO when tied to COM. Oh yeah, so I was correct. So once you get below the threshold, and there'll be a nice graph in the datasheet actually that shows where the threshold is for the voltage on this pin for it to go into shutdown mode rather than just setting dead time. COM OC overcurrent output. Okay, yeah, so it is protection. So you can literally set up probably going to be a simple shunt resistor or something here between some of these pins. So you got overcurrent output, negative logic, input for setting negative overcurrent, positive overcurrent. Nice. So yeah, you can have, by the looks of it, you can have positive and negative rail perhaps being monitored by this chip, I guess. Or it might be positive and negative voltage drop, I don't know. But yeah, pretty cool that it's built in. There's the block diagram of this chip. You can see what it's doing, how it's working, what kind of process it goes through to get to the outputs. And these are going to be the thresholds for how it operates, the input signal, how much of a delay there is between input and the out, and it processing the output signals, the dead time cutoff points, VSD. Here we go. There's the voltage, the VSD, and how much dead time it is. Okay, cool. So we don't actually know that this part is dead. I was just curious to see exactly what was going on there with this. But what we can do is we can take a look on our board now. We can confirm that low side is connected to this chip through the gate resistor. Make sure there's no breaks in the traces. So this was the low side here, which is going to turn into this side. So the gate is that one there. So let's see. Yep, so we do have continuity to pin 1, 2, 3, 4, 5, 6, 7. So that's correct. We're going through the 10 ohm resistor. It always reads a little higher on diode setting. So 10 ohm resistor between the LO, low output, and the MOSFET. So this drive circuit, this driver, I'm actually going to be guessing here that is actually probably working fine. Okay. Now the reason I say that this driver is likely to be fine is because when the driver fails, it often either doesn't turn either of the MOSFETs on, either of low side or high side on, or it turns them both on at the same time because it's just fucked inside and the voltage is leaking everywhere, and it just voltage ends up on low side and high side output at the same time. So the fact that this driver is turning the low side on and not the high side tells me that maybe that's just what it's being told to do. So maybe what's on the input pin of this chip is not actually PWM. Maybe it's just DC voltage. So maybe the chip is actually doing its job. It's literally just passing through that and it's turning on the low side FET because that's what it's being told to do. So what we're going to do now, we're going to plug our power wires back in and we're going to turn the amp on again, and we're going to probe and see what waves are on the input pin of this chip to see whether we just have DC or see whether we have some PWM, some waves. If we have some waves on the input pin, but obviously it's still just not doing anything, then that shows us that it is the output driver there that's dead, but I don't think that's going to be the case. I have a funky feeling that the issue is going to be more likely to be in the PWM generation section rather than in the driver. Ground and B+. What time is it there? It is 20 to 9 in the evening. 8:41. Hey Sam, how's it going, man? Damn, you make amp repairs look so easy. Thanks, man. I appreciate that. They're quite like, if you just think about it logically, like once you understand that amps are just made up of like different blocks of circuits that like talk to each other, it becomes a lot easier to diagnose, because you can say, right, well, the last circuit in the chain, being the output effects, is doing this. So what's before it? Okay, driver. What's the driver doing? And if the driver was dead, it would be doing this to the outputs, which is not, so therefore it's probably not that. You can just kind of like logically work your way back and figure out what's the most likely part of the circuit that's going to be causing the problem based on what it's actually doing. I'd love to see a stream where you dive a bit deep on common drive chips and a focus on explaining how they work with reference to schematic layout, internal function. I could maybe do something like that. Like I say, I never took any like electronics classes or anything like that. So my base electronics knowledge and schematic reading and understanding of typical average circuits and stuff like that is not so great. I'm just a good problem solver. I'm just good at diagnosing problems and replacing parts until they work. So I can try and do something like that. What amp is the hardest to work with? Probably Alpine. Alpine's an absolute bitch to work on. There's like data level stuff floating around all over the Alpine amplifiers. There's like processor chips and like logic level signals and data and the proprietary drivers that you can't buy, and like fucking complicated ass shit that doesn't make this way overcomplicated for a car amp, and it just makes it a massive headache to work on. I've got a T4000.1 that needs repairing. You interested? I'm always interested, my friend, but it's only worth sending it to me if you're in the UK. I just enjoy how friendly you are without an axe to grind. You always put a smile. I appreciate that, man. Thanks. I try and keep it entertaining. Try and keep a smile on my face, even if the amp that I'm repairing is taking 4 hours and I can't figure out what it is. It's all good fun. It's all fun and games. It's all learning curve. I totally thought you mentioned JL audio amps being hard. Yeah, maybe. Although JL audio amps, they're more they are kind of complicated in a way. But for someone that understands circuits a bit better than the average guy, when I look at a JL audio amplifier, it still makes sense, like what's going on. I can see, oh yeah, okay, they've built this drive circuit here, although it's their own drive, it's their own design of drive circuit. I can see what's going on. They use this chip, yeah, that's talking to that, yeah, okay, overcurrent over here. Like the JL audio circuits, I can understand them. The Alpine circuits, on the other hand, I cannot fucking understand them. They are so complex on another level, even compared to JL audio. Why so many JL audio slashing for repair? I don't know. This is the funny thing, right? JL audio, I wouldn't say are a brand that have reliability issues from like myself. No, I can go 2 years without seeing a JL audio amp, but then all of a sudden, and this always happens to me, okay, I will go years without seeing a certain amp or certain brand of amp, and then I'll get like 4 or 5 of them in for repair at the same time, all from completely different customers, all completely random, like just by chance. I'll get so many of them in at the same time, and it's actually really useful for me, because if I get one in that's a pain in the arse, that's got some headache problem that I can't really figure out too easily, the fact that I've got another one that's coming for repair as well with a different fault, I can use the 2 amps and figure out each other's faults from what works and what doesn't on each one. And actually that is what happened with the J Audio Slashes. I did have one that had some ridiculous crazy faults in the VCC voltage generation circuit, and I was able to use another one that came in that didn't have that issue to confirm whether I'd fixed the issue correctly and whether I had the right pulses on the parts and stuff like that. So yeah, I don't know. I don't get a lot of JL Audio stuff in, but at the moment, or over the last couple of months or so, I have I've had quite a lot of jail audio. Would you ever try to repair a computer PSU? Like, probably could repair it. However, I probably wouldn't trust you, even myself, using that PSU on a computer, because if a computer power supply fails, if I repair a computer power supply and it fails again, or I screw up with the repair somehow, then I risk killing like very expensive computer components, graphics card, processor, motherboard, etc. Like especially graphics cards at the moment, man. If like I screw up a computer power supply repair and end up sending like high voltage down the 12-volt rail into the graphics card, then that's like, graphics cards are freaking expensive, man, at the moment, man. Like you want to trust, you want to have faith in your computer power supply, and so I don't even think that people would be interested in a power supply repair. People that are into computers, building PCs and stuff like that, and get, you know, PC gaming, if their computer power supply fails, the last thing they're going to want to do is get it repaired, because there's less faith in that. I feel like people have less faith in a repaired product, a component, than if they just bought one brand new. So I don't even think there's a market for that, and I probably wouldn't even do it or bother with it myself anyway. Condone yourself. Thanks for the 5, my dude. I have a friend's blown JL Slash I've talked to you about before. I still never heard you talk about repairing a Smart 3. I had one Smart 3 in for repair. No, I've never had a Smart 3 in for a legitimate repair. I've had Smart 3s sent to me that the customer just didn't know what they were doing, and the amp actually worked fine, and they had problems in the vehicle and the amp was actually fine. So yeah, I've never had to repair a Smart 3 so far. They've been alright. JL licensed their amp tech from Power Physics Corp in California. That's an interesting fact. Thanks, Kevin, for that. They licensed their amp tech from Power Physics. So you're saying, so you're saying that they didn't necessarily engineer it all in house. They obtained some of the circuit, some of the amp designs from this Power Physics Corporation in California. That's interesting. Did not know that. Like, I mean, but at least they have put the money into obtaining a bespoke unique circuit, rather than just going to a factory and saying, oh yeah, I'll have one of those, I'll have like give me 1,000 of these boards and I'll slap my logo on it, like you find with Scar and even the brands that people nut hug do that. They don't design their own stuff. I have a Rockford 2500 BD here to repair. Nice. They can be a bit of a pain, but they have common issues. So Kevin says, I'm serious, if you pay shipping, I have a motorized servo drive. That's pretty cool. Yeah, I haven't actually had experience with any of those up in person, so that'd be pretty cool. But yeah, dude, Kevin, if you're, I'm just gonna assume you're in the States, just because like the higher percentage of viewers are in the States. The shipping is like going to be $150. Like, it's not worth it. And then shipping it back again, it's the same, and then paying the repair bill on top. And also because they also then have import tax and duty fees to pay. It's not worth it, man. It's so expensive. I work with a lot of data systems at work in the automotive data bus systems. Oh wow, cool. Dealing with that can be a real headache. Didn't know any amps had data. Yeah, in a basic form. Alpine amplifiers. There are logic chips and stuff. There are program chips and ICs, and some of the Alpine amps do actually have like very, very basic forms of computers in them, you know, like a kind of data circuit that talks to itself and monitors stuff. Very, very basic form, but yes, it can be an absolute headache when you have an issue in that area. You can keep it. Oh shit. Well, fuck, maybe. Like I say, the shipping is hella crazy expensive, but like, if you want, that sounds cool. I'll do a stream on it. And get it up and running. Yeah, shoot me a message on my Bevis Facebook page. We can discuss that, my friend. Sounds cool to me. I've had an OCZ mod extreme. Yeah, OCZ. Wait, it wasn't OCZ meant to be pretty high end back in the day? Okay. Anyway, what was I doing? Yes, this Rockford. So, what was I doing? Yeah, we confirmed then that the issue is unlikely to be the driver, which is on the back here, but we don't know for sure whether that's the case. So yes, I was inserting some power wires. We're going to power it up, and we were going to see what's actually on the input pin of. Do I have? Whoa, not that one. I should really hook up a button for the web. I keep having to click on it on OBS and do this. Very annoying. Where am I? Here we are. So what pin was in again? Looks like pin 1. Pin 1, input. Okay. So we're looking for some PWM on pin 1 of this chip, coming from the PWM generation circuit. So let's power it up. And what I'm actually going to do is I'm actually going to probe pin 1 of one of the good channels over here. I want to see, because there's quite a delay between when you turn this amp on and PWM starts on the other channels. So I want to see whether PWM appears straight away, as soon, like on the chip, and then the chip goes from shutdown to active after the delay, or whether it's not, whether the PWM just takes a while to get there. So let's go ahead and probe pin number 1 of this channel right here. Try not to slip the probe and kill this channel in the doing. So the PWM input is referenced to negative rail. Oh yeah, looks like we actually have pulses there right from the get-go. So if I AC couple my scope right here and zoom in a lot, we can see that, yeah, we got pulses right from the get-go here. As soon as you hit the remote, you got pulses on pin 1. And I'm just going to make sure that's the same on all 3 channels. The other 2 over here. It should be, because all 3 channels are working. Yep. Some small pulses. And this is before the self-oscillating environment has actually built. So this isn't what the pulses are going to look like all the time. Oh, okay, this one actually looks a lot better, hey? That actually looks like straight up square waves, whereas these 2, oh yeah, square waves now, okay. So yeah, we do have pulses right from the get-go on these 2 channels. But on our failed channel, what do we have? Do we actually have PWM on pin 1, or do we just have nothing? Do we just have a pulse up to DC on? Looks like we don't have anything. Yeah, it looks like we just got a bump up to turn the FETs on. So, as I suspected earlier, the driver is unlikely to be the issue, because this drive chip is not actually being told, yeah, look, if I turn the amp on, let's give you the scope screen, if I turn the amp on, the input signal just bumps up. See that? It's bumping up. So it's telling the driver, hey, turn the low side on fully. So the issue is not with the drive circuit, it is with the PWM generation. So what we need to do now is we need to work our way back further along the board. So the problem is still present at the input to this drive chip, so we need to work our way back from the drive chip and figure out, okay, what talks to pin 1? What is producing those square waves that's supposed to be on pin 1, and work our way backwards from there. We have a few components surrounding this IRS 20124S chip, and we also have drive cards here on the other side of the board, and I suspect it's going to be some issue coming from the drive card itself. So let's turn the power supply off, and let's make sure we don't have any voltage in the rail caps sitting there still. Yeah, looks good. 0.3 of a volt, that's fine. So we can take our multimeter and we can start tracing our way back, and let's see what's connected to pin 1. Okay, looks like we have a couple of transistors over here maybe. Okay, so we've got a couple of transistors over here. We've got Q43, Q44, which are connected to this pin 1 right here. So just while we're here, let's do a quick diode mode check of these transistors just to get a rough idea. We don't know what readings these are supposed to be, but we can certainly get an idea as to whether they are super low resistance, because if they're like 50 ohms or something, then it's going to be a problem. They're going to be failed. That one seems to be reading what I would normally expect for a transistor. Don't have any super low resistances there. Don't have any super low resistances there. Okay, cool. So that's there and there. So we're unlikely to have, I can just check over here on the what is going to be the PWM generation card. We're unlikely to have any continuity, I think, to the card directly, to pin 1. Yeah, so we don't have any continuity directly from the card to pin 1, but what we probably do have is continuity from one of these other transistors here to the driver card, perhaps maybe through some of these resistors. So let's have a look. And this is at this point where it might actually make more sense and might actually be quicker to grab the schematic out and have a look. I don't know if I'm allowed to show you the schematic or not, because it was passed on to me by my good friend, and I don't necessarily think that it's, yeah, I don't think I'm going to show the schematic on stream, just because I don't want to get in trouble for that and piss anyone off. So sorry about that, but that's why I like to try and do as much of this without the schematic as possible, so you can see, if you don't have the schematic, what kind of workflow you do. So okay, let's have a look at these two transistors then. It doesn't necessarily matter what they are, but I imagine we've probably got an NPN and a PNP, likely to be, that's buffering this input signal to the drive IC. So what we want to go ahead and do is take a look at what's on the other sides of them. So we've got the PWM going into the chip on this pin here. Now on the other side, on the other two pins here, we've got this pin here, which is connected to this transistor here. Oh, we have a short between this pin and this pin. Pins 1 and 3 of this transistor are reading short. Now that might be by design, that might be intentional. Sometimes you do actually have that, and by the look of the trace I can see the trace might actually go to both legs, so that might actually be intentional. What we can do is, because this is a 4-channel amplifier, like what I was saying earlier, it's very convenient because we can go down to one of the channels that we know works and we can compare, we can confirm whether that's actually the case or not. So pin 1 from this good channel going to this transistor going into this one, and yes, it is supposed to be connected. These two pins actually are connected by a trace, so that's then confirmed for us that this part is unlikely to be bad. That's just the trace that we're reading rather than a short on the component. Okay, cool. Let's go over here and let's just, I think this probably goes to ground actually. Let's have a quick look. Does this go to ground? Yeah, okay, this goes to ground, so I wonder then whether the signal is coming through this side or this side. Okay, I think the signal was probably going to be coming through this transistor side here. So this is the one that we've got connected to the driver. On this leg here, we have it going to a resistor R141, which is then going to ground reference for this circuit, which is actually negative rail. Don't think it goes anywhere else. Nope, it doesn't. So we're likely to have the signal coming through on this side. So the signal then goes here to this transistor, which has continuity there. And it also seems to maybe have continuity here as well to Q40. So we go to Q40, just check we don't have any shorts on Q40. Q40, does that go to ground or negative rail or anything like that? And this might be part of the circuit which applies the signal to negative rail reference. So when the signal comes out of this driver card here, when the PWM signal comes out of this driver card, it might not be referenced to negative rail yet. It might be referenced to main ground, and then it might need to go through this circuitry here to kind of transfer that drive signal onto negative rail, because the drive circuit, its ground is negative rail. So we need to apply that signal to negative rail so that it's oscillating around negative rail, so we can use negative rail as ground reference, if that makes any sense. So yeah, we're likely to have the signal coming through here. So I imagine that on one of these transistor legs here, we're going to have continuity to the driver card over here, which is going to have the PWM out on it. So let's just go ahead and see whether we have continuity from any of these legs to this driver card. And that's probably going to be the one with the signal on it. And we're doing this a long way around, but we could just confirm that with one of the other channels that currently works. And there might be a resistor actually in between. it might not have a direct connection. There might be a resistor on the other side of the board anyway in the way. So there we go. So we have continuity. Q40 has continuity directly to one of the pins of the driver card. So what we can do is we can have a look at another channel here and get the same pin and power the amp up and see whether we have the PWM on the same pin as this one, and that will tell us whether that's actually where the signal for the drive circuit is originating from. So let's power this up and let's go ahead and probe that pin of one of the working channels. Oh yeah, looks promising. Looks like we did. Let me just AC couple that. Yeah, there we go. That's the same signal that we saw on the input pin to the drive transistor, but it is actually referenced to negative rail already. I had to AC couple the scope there, you see. So, okay, that's one of the working channels that has PWM out on this pin. So we found where the signal originates from the PWM generation circuit, or the drive origination circuit. So if we now probe this pin here, do we just have DC or do we actually have some signal? Ah, we have signal! Okay, that's a relief actually. I see why that's a relief, because I did not like the idea. I mean, it would be pretty easy, but it's nice not to necessarily have to remove this whole driver card and start poking around in there. So we actually have PWM coming out of the driver card for the channel that has the problem. See there? Nice looking PWM. But it's not making its way through this little circuit here of transistors, probably some resistors. It's not making its way to our drive IC over here. See? We just have DC there. But we have PWM here. Yeah? Cool. So I think we've honed in on the area that has the problem. Oh my gosh! Holy shit, fuck man. Bearded Gaming, what are you doing? Rolling up here with a 50. Holy shit, my dude. Thank you very much. That is a lot of money to give to some random guy wearing a backwards hat and a camera stuck on the front with some gaffer tape on the internet. Holy shit. Want to see a video of that. To help on shipping. Thank you very much. Holy shit. That is very kind of you, my friend. Okay, well, let's do it. Yeah, Kevin, shoot me a message on the old... if you go to Facebook, type in Bevids. My page will come up. Click on message and shoot me a message, and yeah, we'll get chatting after the stream has finished. If you're not on Facebook, then what's the best way to get in contact with me if you're not on Facebook? Don't really want to give my number out on stream, obviously. If you're not on Facebook, leave a comment on this stream, on this video. Once this stream is finished, it will turn into a video on my channel. Leave a comment on there, and then I'll reply to you with an email address that you can contact me on, and well, we'll get something sorted out. I have 4 amps in my car now, no blown lamp. Is this luck? Partly, amps can blow randomly just through normal component failure, so there is an element of luck in that. You can be using an amplifier absolutely perfectly, you know, you can be using it with no issues, not doing anything wrong whatsoever, and it can just blow just because the components can fail by themselves. So there is an element of luck, but sounds like you might be, you know, using them correctly. You're not mounting to the enclosure, or if you are, there's not excessive vibrations to the board. You're not clipping or demanding excessive current through the board. So yeah, it is it goes in hand in hand. A bit of luck and a bit of using it properly, and you should be fine. Rockford has good warranty department. I sent back a 3-year-old T-amp that they repaired in 3 days, shipped it back free of charge. Holy shit. Wow, 3-year-old one. That is incredible. Like, you wouldn't even get that service on so many brands over here, having only had the amplifier for a month. You would have to pay shipping or something like that, or they would say, oh, it's user error, you wired it up backwards or some bullshit like that. fucking hell, man. Yeah, thank you so much for the 50. That's absolutely ridiculous. That's going to help out massively. Well, we'll get that amp over here. We'll do a stream. Have 10 of these, so giving one up isn't a big deal. Don't use them much anymore. Better tech is available. Tapped horn subs. Yeah, man, tapped horns are awesome. I want to get a tapped horn pillar in here. I've got a really nice, it might sound silly, but it's a 6.5 inch woofer, but the TS parameters lend itself very well to a tapped horn, and one of my good friends, who is an absolute genius at enclosure design, especially on horn response and stuff like that, has actually modelled a custom horn for that driver that on paper at least performs phenomenally well, so I do definitely want to get that up in here. Anything besides Facebook? You know what, I'll drop my email address here, my business one. So my guy Kevin, shoot me an email over to this email address that I've just typed in the live chat, and yeah, then we'll get it looked at. Have you ever worked on the Pioneer PRS 2000 SPL? You know what? I think I have. Actually, I might even still have. I think I still have one of those laying around. Yes, I have. And what was the question? What can you say about it? Very old school Class D design. Everything was discrete transistors, building the self-oscillating environment, drive circuit, etc. It was built, the build quality was great though. It was a fantastic build quality, especially for the time, and it made really good power for its compact size for that time as well. It was not the most resilient in terms of vibration damage. The one that I had suffered from some vibration damage issues, and a bit of a pain in the arse to repair, because a lot of the components and transistors and the way that the circuit was designed, it was designed with the components that were available at the time, and substituting them in with new components, the circuit isn't as happy. It was designed around the exact tolerances and the way that those components at the time worked, and you know, their kind of behavior. And the modern components, you have to really mess around and try a bunch of different modern components just to see how they're performing there. So cool amps though, really cool amps for their time. That's not to say that they're a good idea to buy now, because time has moved on for sure, and you can definitely get much better efficiency, much better sound, much better amplifier for less money probably than someone would ask for that thing, because you know, people would probably put the price up. You know, people would probably ask a fair amount of money for an old amp like that. Oh, collectors, you know, rare old amplifier. And my man Wazza, shipping fund. Are you accepting more amps for repair? Yes, of course I. Yeah, I'm accepting amps for repair every day of the week. Thank you so much for the 20. That is insane. Working our way up to getting the shipping paid for for the Rockford amp from Kevin. Wow, holy shit, thank you so much, man, that's insane. What consistent day of the week do you usually have a slow work day? It really depends, my man. I don't have a work schedule as such. I will jump in the workshop as and when it's convenient for me, and if I've got a lot of work on, then I'll be in the workshop more often. If it's quiet, then I won't be in the workshop, I'll be working on other stuff. So there's no schedule, or there's no pattern at all to really what day I'm working. Okay, so turn the power supply off, and right, we might actually want to turn the power supply back on, because we might want to follow this PWM through this circuit. So we found then that we do have the correct signals coming out of this driver card here, and but it's not making its way through this circuit into the input of the driver there. So into the drive IC. So where are we going? We start off here at Q40. So actually, I guess what the thing to do would be to power the board up again and follow the drive through the circuit and compare it to one of the good channels. So let's zoom out a little bit. Let's have a look down here. We've got one of the good channels down here. So what we can do is we can follow the wave through the circuit to find where it goes wrong. So on this good channel here, it comes in at Q23, and then I guess we'll just follow it through, see where it ends up. Q23, where does it go from Q23? I assume it might go into Q24 perhaps. Maybe, yeah, it goes into Q24. Q28, we've got connection there from there to there, same as we have with that one. I'm just going to make sure that none of these are shorted or anything. I think we checked that already. Now, do we have any resistors kind of going on? Because we could have a resistor that's out of tolerance. So we have a resistor R139 connected here to Q41. And that is a, what is that? That is a 3321. So that is a 3320 ohm resistor. So let's just make sure that that is within tolerance. It's reading as a 3K on the board, probably because there's some other components in parallel with it. So I just want to go ahead to the good channel, make sure that it reads the same on the good channel. Yeah, it does, so that resistor is probably fine. What other resistors do we have around here? We have, what does this one read? R140 is a 50 ohm, or actually it's a, I think it's meant to be a 49.9 by the looks of it. And same goes for that one over here, they're fine. What's Q42 doing way out here? Is that part of the PWM? It's not shorted or anything. Right, let's power the amp back up then, and let's follow these pulses through the board, through these components, and see where they get lost. So, coming out of this pin here, I have the pulses just there. I'm going to zoom in a little bit on the scope so it's a bit easy to see. There they are. So we go into Q40, I think is at this pin here. So that is the same as going into Q23 over here on this channel. So do we have pulses on the top pin? Okay, no pulses on the top pin, but we do have pulses probably going to be on this pin here. Very, very small. Very low voltage pulses on the, what I'm going to call the output of Q23 and therefore of Q40. So let's see, do we have pulses coming out of Q40? Yes, we do. Although they look a bit bigger. Now that's interesting. They look a bit bigger coming out of Q40 than they do coming out of Q23. That's probably because they're not being pulled down. So the issue is going to be after Q40. So obviously, whatever is connected to the output of Q23 and Q40, there's going to be a little bit of a load on that output, right? So on the channel that works, the voltage coming out of Q23, and on this other channel all over here, another channel that works fine, the voltage is, the amplitude of the wave is quite small because it's being brought down by the rest of the circuit, the load on it. Whereas it doesn't look like any load whatsoever on this one because the amplitude is higher. So okay, so it's going to be one of the components after it. So what happens after it comes out of Q40? Do we go into Q41? Okay, no PWM on Q41. Okay, we have high amplitude PWM on this pin of Q41. Q41 on the top pin, we have no PWM. Let's check that on the good channel. So we're coming out of Q23 and we're going into the one next to it, which is this one here. We have PWM on that one there. And do we have it on the top? Ah, yes we do. So that's probably maybe going to be the component that's the problem. But we want to check the voltages, the DC voltages on it as well. So on a good channel, we come out of Q23. So we go into Q23 there with pulses. We come out of Q23 with pulses that are a lower amplitude. We go into Q24 on what I'm going to call pin 3 over this side. And we come out on this top pin, pin 2 over here. Whereas on the bad channel, we go into Q40 with a high amplitude wave. We come out of Q40 with still quite a high amplitude wave, not quite as high as it is going in, but still higher than it should be. We go into Q41 next to it, and we don't come out. Now, whether that's actually an output or not, it might not be an output, it might be like a feedback. So the reason we've not got anything on there might just be because we don't have anything on the input pin, if that makes sense. So we shouldn't necessarily start blaming Q41 right away. Let's have a look at Q43. Let's go to Q43 version on the good channel, which is Q26, the next one along. Let's see what we have on here. are we supposed to have any pulses on here? So we're supposed to have pulses on what I'm going to call pin 3. And nothing on pin 1 and 2. So what's going on Q43 over here? So pin 1 and 2 we should have nothing. Yep, and pin 3 we have nothing either. So it is looking more like Q41 is the culprit here, perhaps. Yeah, I think that might be the culprit, because unless we have PWM at any of these other transistors, there's nowhere else that it's going. Yeah, so it looks like Q41 might be the culprit here. And condone yourself, another 5. Shit, thank you so much, man. I won't use a sub amp without a remote clip light. Yes, that makes sense. Why would you, if out of all the amps that you've got to choose from in today's market, a clip light is so useful. It's so handy. Why would you choose an amp that doesn't have a clip light, given all the options of amps that do have clip light on the market today? I absolutely agree. Smartest thing I've done was take the clip light off the board and use a speaker wire to extend it to the dash. I have also thought of doing the same thing. I also had another idea that gave you the same end result without having to desolder or solder anything. What you can do is you can take some optic fiber cable, yeah, and you shove it in the clip light. You make a seal, a tight seal around the clip light on the amp, so that all of the light from the LED goes down the optical cable, and you just bring the optical cable up front on your dash somewhere with a little like a diffuser panel or like a little dome bulb or something like that, you know, like a little plexiglass thing to diffuse the light a bit coming out of the optical lead. And then you've got a clip light on your dashboard that hasn't actually required you to run an actual cable or do any desoldering or damage the amp in any way. You're just transferring the light from the clip LED up front. It's a pretty cool idea, huh? I have two 2500.1 BDCPs. Oh wow, we've got a shitload. T1000.1AB, two P600, 4 ABs, two FI SP418s. Wow, yeah. 4 8.8 inch Negas. I don't recognise that one. That brand. Glasgow Sound Damping, Moscone Aerospace. Wow. Going strong for 5 years. That's fucking awesome. That is a long time for a system. Like, guys, how many people do you know that get a system installed, get a system up and running, and like a year later, or even less than a year later, they're ripping it out and building it again, or they're changing subs, or they're changing amps, or something's happened, or you know. To have a system for 5 years that is the same is fucking awesome. That is a testament to the equipment, and also the fact that it must be great. It must sound fine. It must sound beautiful for you to want to keep it like that without, you know, ripping it all out and changing it again. So that's pretty cool. What's up? What's going on? I was asking because it would be great if we could get a chat room amp repair like Streamless you did. It was great to see where our knowledge is amongst us all. It would be great if we could get a chat room amp repair. Did I do one of those things on during Streamers where I didn't do any repair? We just did a kind of a chat, or like I think I did a lesson that I did. How does Class D actually work with how it varies the duty cycle of the PWM to give you a sine wave. Do some streams like that if people like. Had an old Buick that had optics running to all the lights on the car, so you would know when you had a bulb out. Ha! No way! That's hilarious. That's fucking hilarious. No way! Had optics running from all the bulbs. That's hilarious. Alright, cool. So I guess the rail voltages should have disappeared by now. So we're going to go ahead and just, I think what we're going to do is remove Q41 and drop it in the transistor tester just to see what it says, see what it reads. We're suspecting that Q41 is bad. So let's go ahead and get the hot air gun turned on. And yeah, let's get that part removed. Hi guys, hi up there, how's it going? Wait for that to heat up. What do you reckon, guys? Do you reckon that we're on the money? Do you reckon we are on the ball with Q41 being the bad part, or do you think it's something else? I can't really see how it could be anything else, because it comes out at Q40 and goes into Q41 and doesn't come out and isn't present anywhere else. So oh, you had us fix the amp. You were our hands. That was a funny stream. Then we had Kian come in and oh, that was a different one. I think I did two, didn't I? I did one where you guys fixed the amp through me, but I told you what you were doing wrong, kind of thing. I didn't let anything bad happen, really. And then I did another stream where I literally did exactly what you told me to, and Kian came on with a troll, with the troll antics, and told me to short the negative rail to the high side gate or something like that, and powered it up and fucking killed everything. I've noticed some PA speakers had light bulbs in their crossover. What would that be for? So a light bulb is going to be a form of current limiter, I imagine. So what the light bulb is going to do is when the light bulb has lower current passing through it, it's going to be at a low resistance, okay? And when you start passing higher current through the light bulb, it's going to, the filament is going to get really hot and illuminate, and by doing so its resistance is going to skyrocket through the roof, therefore limiting the current to the component on the other side of the bulb. Wait, why am I talking? I'm talking to that camera. I can't forget what camera to talk to. So yeah, a light bulb, yeah, it works in that way as a I guess like as a kind of low resistance current limiter, all the while that the desired current is passing, and then when overcurrent passes, it suddenly becomes high resistance and saves the rest of the circuit on the other side from damage through overcurrent. So that's probably what it's going to have been used for. Evening, Matt K. How's it going, my dude? Have you bought your oscilloscope yet? I keep talking to that camera. That one. That camera. That's the one that's current on. How long have you been live? YouTube didn't tell me. We've been streaming for a grand total of, what is it? 1 hour, 1.5 hours, 1 hour 30 so far. Holy shit, 110 viewers? My guys. My guys. The boys are on the stream tonight. Right, let's get it off then. Let's get Q41 off the board and see if we were correct. So that is actually the problem. Now, Rockford boards have a nice high thermal mass, so this might take a while. I probably could preheat the board with the big gun first, but let's just preheat the board with this small one. It'll be alright. You see this is really high quality PCB, guys. This is really nice, nicely assembled amplifier. It does just mean that it's probably going to take a little longer to desolder. Now the reason that I'm drawing circles around it is I want to preheat the area around the component that I want to remove. The reason for that is if I start just holding the gun on one specific spot, then I risk blistering the board. It can heat up the air in between the board layers so much that it expands and causes a blister to appear on the board, which is not what you want. Right, that should be enough to get this Q41 off. Like, this board is such high thermal mass. Honestly, this component would have come off absolutely ages ago on any other amplifier. There we go. Starting to come. I think we've got a little bit more. A little bit more. There we go. She's off. Okay. So let's dump this onto the transistor tester. So it's not reading a short. This transistor wasn't reading a short circuit, so it's not obviously dead. But what we're going to do is drop it onto the transistor tester and see what the tester says about it. See whether it can read it as a transistor, or whether it's got any funky values or anything like that. There we go. I'm just going to wait for it to cool down a bit, because when it's as hot as that, when it's like 200, 300 degrees, you know, it might not read correctly anyway. Joe Bound says, I purchased a refurbished amp, and is there any way I could send you some pictures of it and you look at the repair and let me know if you would do anything with it. So Joe, if you're on Facebook, then all you need to do is type in Bearvids in the search bar, hit enter, click on my Bearvids page on Facebook and send me a message with the pictures, and I'll check it out for you, let you know what I think about the repair, etc. Low Bass Addicted says, I have an amp. When I turn it on, power, protect and clip LEDs stay on and the transistors get hot. What's going on? So it sounds like if the transistors are getting hot, then you either have a drive circuit fault or you have a short circuit on part of the board, and the reason the transistors are getting hot is because they're trying to drive a short circuit. They're trying to dump all their power and it's just getting shorted to ground. So tell me what amplifier it is, because I'll then be able to give you more information about what the common faults are on that specific amplifier. Okay, I think it should be cooled down enough now. So I'm gonna be pretty pissed off if this reads correctly as a transistor and seems to have the right values. Then it's gonna be a bit confusing. But oh, also look how clean this is. Look how clean my transistor tester is. It's still a bit janky on the sides, but I gave it a little clean up. I'm actually making a video at the moment on what equipment you would need if you want to get started in amplifier repair, and I just knew that if I showed my transistor tester in the video in its jank ass form that it was, with like flux everywhere and like amplifiers that come in with the power supply blown, they got ash all over the inside, which gets onto my fingers, which then gets onto there, so it was all black and shit. So I knew that I was going to get comments like, "Oh damn man, you clean up your stank ass shit. Why your keyboard all jank is stanking up like you dirty ass motherfucker?" So I thought I'd clean my shit up before I did that video. Right, what we saying? Oh, well, damn. Okay, it reads it as a BJT PNP. We have a current gain of 236. So the issue might not be the transistor then, it might be that this transistor isn't being supplied with the correct DC voltage current in order to pass this waveform on. So if it's not the transistor that's the fault here, then it's likely to be that the transistor isn't. So we know the transistor is getting the pulses on one of its inputs and it's not outputting the pulses where it should. But the reason it's not outputting the pulses might be because it's not getting any voltage reference to apply the pulses to, if that makes sense. Although this is a PNP, I see, this is the thing, this is where my knowledge falls down a little bit because I didn't take any electronics classes and stuff like this. So this might be a very common, a very basic style of kind of transistor pairing circuit. You know, oh, it goes through there and then there's meant to be voltage on that and that pulls it to ground. Like, so I'm not too familiar with this. I can just troubleshoot it the best I can. So, okay, that transistor might be actually fine in that case. Now, the way that we can check that for sure is we can remove one of the transistors from the good channel and test it in the tester and even swap their locations and see if anything changes. So let's do that. Let's take off the same transistor from the good working channel and let's drop that in the transistor tester, compare its readings, to see if its current gain is the same, its HFE is the same kind of area, and then swap them round and see if the channels behave the same. Thanks, Danny, for the kind words. I appreciate that, man. I'm glad that it's enjoyable to watch. So just cooking up this board again, getting some heat soak. Don't want to blister the PCB because this does require some pretty heavy energy to melt these solder pads. There's a lot of thermal mass in these Rockford boards. They're very thick, very multi-layer PCBs. Okay, that should be enough. Now we just hold the heat on the component, and eventually it should melt up and come off the board. I'm moving it side to side. You don't want to just hold the hot air gun still for too long, because you burn the PCB or you damage a component. So you want to keep it moving around. You want to keep it, there we go, keep it moving around. So okay, let's get this this transistor off the tester, this one from the bad channel, and let's drop the transistor from the good channel on the tester and see what it reads. See if it reads the same kind of current gain. Wait for it to cool down a bit. Actually, it's not soldered so great. I'm just going to reflow that a little bit. And the thermal mass on the tester pads here is very, very low. It melts very, very quickly, almost instantly. Yep, there it goes, melted straight away. You can see the difference there between the high thermal mass amplifier board and the low thermal mass tester board. Sam, have you ever repaired a tube amplifier or guitar amplifier? No, I have not, my friend. I have not repaired any of those things. Ever try to design your own amp? Eventually, it's something that I want to do eventually. It's a future goal, a life goal of mine. Yeah, I'd love to design my own amplifier, but truth is, knowledge just isn't there yet. I might be a good problem solver, troubleshooter. I might be able to repair quite well. But yeah, the knowledge isn't there yet to actually come up with an amp design from scratch yet. I could probably be okay at maybe... I could maybe be better at fine-tuning an amp. So if someone else designed an amp from scratch and then sent it to me to kind of look at to see how optimized it was, how well designed, how the amp was actually performing, and whether it was all super comfy and relaxed, whether it was chilling or not, I could probably do that better. Okay, so this is the component from the good channel. Yeah, so yeah, it's reading the same it's reading the same kind of values as the one from the bad channel. So the issue then is unlikely to be that transistor. But just to confirm that that is not the case. Thanks, Matt, for the 5. Appreciate that, my man. Cheers, buddy. Very kind of you, my friend. What I'm going to do is I'm going to put the transistor from the bad channel in the good channel and transistor from the good channel in the bad channel, just to see what happens, because if the transistor is fine, then it doesn't matter which way round they go back in anyway. So it will just help us out a little bit more to confirm that that's not the issue. Okay, there we go. So those two transistors are back in the board. I have swapped their locations. I'll wait for it to cool down for a minute. And I'm going to power it up again just to see if anything's changed by swapping those round. They both read fine and they both read the same on the transistor tester, so I don't think that's actually going to be the issue. The next thing I'm going to be looking at is I'm going to be looking at what voltages are on the other pin of that transistor, because that's where the wave disappears. It disappears at that transistor. That transistor isn't passing it forward on further down the circuit. So the problem is either going to be that transistor is bad, which we've just shown that it's probably not, or that transistor isn't either connected to a ground reference properly, or it's not connected to a supply voltage correctly for it to be able to pass on that wave correctly in the first place. You are inadvertently one of the best sponsors for Right to Repair. Have you ever tried to reach out to others like Lewis Rossman to collab on the issue? Like, I don't feel I'm not big enough. I'm not a big enough deal. I'm not a big enough. You know, I'm just some random little guy repairing a very, very specific niche type of circuit. And in the car audio industry, I haven't really been hit by any of the issues that the likes of Lewis Rossman has to deal with Apple and stuff, making his line of work more difficult. I don't really have that problem, so but by all means I support right to repair, like for heck, you know. Obviously I just don't know if there's anything I could bring to the table, really. I'm not sure how the hell you guys have the level of patience it requires. I personally would be into it for about 2 minutes and then be thinking of something else entirely. I enjoy it, man. There's a certain satisfaction. There's an amazing feeling that you get from taking basically a doorstop that doesn't work, something expensive that literally just doesn't work, and troubleshooting it, finding the culprit, repairing it, and turning it back into something that works. It's a really great feeling. It's like, shit, yeah, it works again now. This is now a useful piece of equipment that can do things rather than just being rubbish or like a paperweight. You know, it's a satisfying feeling. Did you watch the new photonic induction videos? Holy shit! Wait, new ones? No, because I know he came back, didn't he? He came back from the grave. He came back from the grave basically after years and years of not posting, but then he posted like 2 or 3 videos and then didn't do anything else. Has he posted any more? Actually, you know what? You sparked my interest. What is going on with Photon right now? Has he posted anything since his little comeback? Nope, he hasn't. 5 months ago, still nothing. What's going on with this guy? Like, oh. You see, he disappeared. 4 years, yeah, and then all of a sudden, boom! 7 months ago, what happened to photonic induction? Then he released a bunch of these new videos. Awesome, it was going really well. He seemed healthy and happy. And then August, then nothing. And you can see all the comments are like, gone again. He will return. Where is he? There, and he was there, gone. So yeah, really weird. Don't know what's going on with Photon. Sam, the other week I asked about bench testing an amp, but forgot what you said. Then I saw that post where that guy about not believing those 2,400 watt amps. Can you do a test? Or yeah, so I don't actually have my high current power supply set up, but because that guy he wanted to like send it to me to prove a point or whatever, and because I know that those amps bench 1,400 watts, I could very easily quickly hook up a power supply to bench that. So. Yeah, I could quickly hook up a power supply to bench 1,400 watts RMS, that's fine. Oh no! I see Verstappen spanked his car into a terminal grave. I was watching the Le Mans 24-hour the virtual, but I started streaming, so now I can't watch it anymore. I was watching Jimmy's live stream, Jimmy Broadbent's live stream. I was getting really into that. He just started a new stint actually, just as I was coming live. I hope he's doing alright. Should we check up on our boy Jimmer? Should we see what he's... just real quick before we get back into the sound, should we see how our boy Jimmer's doing? I think I can stream his stream without any copyright issues, can't I? How's our boy doing? Oh, it's got dark, okay. He be steering! Has he got damage? Let's check if it's...
Too caught up in being the best F1 driver of all time, you know, to...
What position is he? 40? Is that 41? So I think he's not last anymore.
Yeah, I'll do it on the straight.
5 seconds to the guy in front, and then 3 minutes. Yeah, he had a really bad luck on this one. Cool. Good that he's still going. Good that he hasn't binned the car. But wow, Max has binned it. I'm going to have to check the highlights later. Anyway, back to the repair. I still have my hot air gun on. Right, let's power this up then, and let's confirm that nothing has changed after changing those transistors around. And let's check between the good channel and the bad channel to compare voltages on Q41 and Q24. Which is the same transistor, same position transistor in each channel. I might actually need to, yeah, I'm just going to manually drop a little bit of solder onto one of these, this Q24. It looks like it's soldered okay onto that pad, but I don't super trust it. So I'm just going to drop a little bit of solder from the iron on there with a bit of flux, or actually just flux it in. Flux on there. How much can I zoom in with this camera? I can zoom in quite a bit, hey? Okay, that's the limit right there. Yeah, that's the limit right there. I can't zoom in any more than that. Sausage curb into the wall. Shit, I jumped the sausage curb, isn't... Oh, fuck. No way. That's wild. So that's not only Max out. Well, is he out completely then, or is he just like lost in a bunch of places, like a heavy repair pit stop, or is he out? Because I know that the guy, I can't remember his name, who's driving for Mercedes, he either accidentally downshifted from like 4th to 1st gear and blew the engine up, or there was an issue with his wheel, and it just duplicated the inputs of the downshift. And I know that he's out as a result of that, which is not good for that, but holy shit. So if Max Verstappen is out, then that's probably going to put more of viewership onto Jimmy, maybe. I know that Max and Jimmy aren't the only guys racing, aren't the only guys with a following, but big following for Max. If he's not racing anymore, if his team isn't racing anymore, then I imagine a lot of the people that may be watching Max will jump over to Jimmy's stream. Are you able to get your hands on the Ground Zero GZPW 15X Max subwoofer? Yes, there is a distributor in the UK. I'm not a massive fan of them. The distributor's great, they're fine, but I mean the sub I'm not a huge fan of. I'm sure it's to do with the lack of views, or that he's been arrested and charged for use of high voltage systems in domestic premises. I'm sure. There's always loads of rumours though about all kinds of stuff. Like when he was gone and disappeared last time, there was all kind of rumours floating around. So I'm sure we'll find out eventually what happened. But I don't think he was doing anything illegal. He's a professional electrician. He knows what he's doing. I would have thought he would have checked all that stuff out before posting any videos like that. So you don't have to be big to be an advocate for right for repair. Everyone should be an advocate. It saves the environment and money. Okay, I'll definitely check it out. Jim has just passed him lap-wise. We celebrated. Oh wow! Okay. Holy shit. That must have been good to see. Oh, I'm kind of annoyed that I'm not watching Jimmy stream now, but I'm streaming myself. So, okay, what am I doing? Yes, power this up and see what we have. So this is the bad channel. Let's just check that nothing has changed since we changed those parts around. So we have voltage we have PWM going into Q41. small, and we didn't have anything coming out before. Yeah, we still don't have anything coming out of Q41, which will mean that we still don't have anything on the input pin of the IC. Let's just make sure that the good channel, we haven't nerfed it. Yep, the good channel was still fine. Good channel being down here, that's still fine. Still got PWM on that. So it's not Q41. That is the problem. So let's confirm what voltages we have on Q41 compared to the good channel then. So on Q41, we have... Actually, I'm going to get a reference for negative rail. I'm going to hook up another oscilloscope probe, channel 2. I'm going to latch that onto negative rail, so I've got a reference for negative rail. The reason I'm doing that is because negative rail is the ground reference for this circuit. So I want to have a reference for the ground for this channel on my scope, so I can easily see. Now, where is negative rail? I think we've got some rectifiers over here, perhaps. Looks like we've got negative rail over here. That might be a... I'm looking for the rectifiers. Where are the rectifiers on this board, guys? Where is the rectifiers? I just want to grab a negative rail reference. Oh, here we go. Right over there. Here's the rectifiers. Yep, there we go. So negative rail is this one, this rectifier right here. Okay, cool. So, whoa. Fuckity fuck. Right, that's negative rail. Okay. So, Q41 then, we already know that we have PWM coming in on pin 3, I'm going to call this. And that's actually quite a way above, oh no, I've got different, there we go. So yeah, PWM coming in on pin 3, and it ends up being above negative rail. You can see there. Oh hey, yep. Okay. And then nothing on the output, we just have, yeah, DC. I'm gonna go to 20 volts divide. So you can see there, this is where the DC signal comes from. This is where the DC signal originates from, which is why our low side MOSFET is turning on fully. So we have PWM on the input of here, of Q41, but then on what is likely to be the output, we just have DC, which is what's causing the MOSFET to turn on fully. Now, what is on the top over here? We have what looks like, how many volts above? I'm going to change my scope screen around a little bit so I can see clear messages. Let's get some readings on the scope here. For channel 1 and 2, so voltage on channel 1 of VRMS and frequency channel 1, and then I want channel 2's voltage RMS as well so we can get a comparison. Okay, so let's pause that there. So it looks like we've got about 8 volts difference there between negative rail and what is on pin number 2. So this being pin 2 of Q41, got about, yeah, on the scope screen there, got about 8 volts, positive 8 volts reference to negative rail. So let's just see whether that is the same on the good channel. So I go down here to the good channel, Q24. Ah, no, we actually have PWM. So that's what the issue is then. The issue is that there's no PWM on one of those. Okay, so where does that come from then? So we're supposed to have PWM on pin 2 as well, which we don't have over here, so that's the issue. So what's that connected to? That goes over here. Looks like it goes over here to the top of the PCB. Just have DC there. Okay, interesting. Right. Let's wait for that rail voltage to dissipate from the board. Actually, we can even short it out through our resistors to get rid of it nice and quick. There we go, all gone. Right, so let's take a look at this then. Pin 2, we're supposed to have PWM, but we don't have any. So what is pin 2 of Q41 connected to? It's connected to Q44, which Q44 is connected to pin 1 of, no it's not, it's Q44. What was connected, which one was connected to pin 1 of the drive IC? Was it Q44 or Q45? It is Q44. Okay, so that is a feedback then. That is like a feedback kind of thing. So in that case, then it might actually be the drive IC that's bad. So we have PWM coming into Q40. Then Q41 is the kind of next one along where the PWM goes, and we have a connection there to pin 1 of the IC, which is the input, and to Q43. So what's Q43 connected to? Is it connected to ground or negative rail? Right, negative rail on Q43. Q43 pin 1 is connected to what are you connected to, pin 1 Q43? Because I think you're going to be important. Connected to R139, and the other side of R139 is connected to the output of Q41. So it looks like we have the Q41, so the PWM comes into Q41 here, pin 3. Q41, PWM looks like it's supposed to come out of there, into R139, through here to Q43, which has negative rail on it as the kind of supply of the ground. That's going to be like a pull down perhaps, before then going to pin 1. Now is R139 connected to anything else? Because that might be an issue as well. We have this capacitor over here, we have this resistor over here, R142. Okay, what is that then supposed to be on the good channel? So if we go down to a good channel, we have this one here, connected over here. So what is that resistor reading as on the multimeter? We have 634 on that resistor next to that cap. So let's go back over to this side. 634, yeah, that's reading correct. So it's not that. Ah, interesting. Okay, we have a variance. We have a slight difference in reading over here. Right, so I've got my multimeter set to diode mode, okay? Now there's a resistor up here which is R138, which looks like a 2002. So let's just check the resistance on that. 7.69K. 7.69K one way round, and the other way round, because it might be different the other way. No, it's the same the other way around. Okay, so let's go over to this side. 7.69. Okay, so the resistance is the same as the good channel, but on diode mode, we actually had something different between the good channel and the bad channel. So the bad channel, one way round, we read pretty high value there, 1960. One way round. If we flip it round the other way, we read 694. Now on the good channel, one way round we read 1396, and the other way around we read 90. So we have quite a difference there in value for diode mode reading. So let's see. Let's turn our attention over here then to this kind of area. So we've got this resistor here. What's this all connected to over here? It might be connected to some components on the top side of the board, because we do have some traces here, some vias going to the top side of the PCB. So there might actually be failed components on the other side of the PCB. We have continuity there through to R136. Let's check that that's the same on this one. Oh, okay, we actually have continuity between the channels, so this is going to be a supply voltage that is shared. 32 ohms between these channels here. Okay. Six, 4, 4, 14. 14. 6.2. Okay, I'm going to flip the board over, and I'm just going to see what components are on the top side of the board around this area. So I'm curious to see what's if there's anything on the top of the board that we can kind of measure and see if there's anything bad. So let's go over to the top side of the board and let's have a look around this area. It doesn't really look like there's a bunch of stuff on the top of the main PCB, but we do have a lot of stuff on the driver card here, obviously. Now, I was saying that I didn't think that the issue was on the driver card itself because we had PWM coming out of what's likely to be the driver card output pin. It looked good, but it wasn't making its way to the driver circuit. So I still don't really think the issue is on the driver card itself. I think the issue is on the little circuit around here. So let's keep our attention on here and let's see what we've got going on. But you know what might just be something that we could quickly do that would there's something that we could quickly do that would turn our attention away from all of these transistors here. Is we could just swap all of these transistors for all of these transistors on the good channel, just because we have a working channel here, so we have the ability to just quickly do that. You know, just as a kind of blind swap over, just to see if the issue is swap sides. We have that option there to us. It's quick and it will tell us a bit more about what the fault is, where the fault might be on this circuit. So I think that's what we're going to do. We're just going to go ahead and swap the rest of these transistors over from the good channel to the bad channel to see if the problem changes or moves channel. That's a quick thing we can do just to help us out, speed up the repair a little bit and speed up the diagnosis process. So I'm just going to apply some flux to all of these parts over here. Now we don't need to change Q24 or 41 because we changed those around already. Now we're going to do these one at a time so that we don't get confused. Here comes Q40 first. A lot of thermal mass on these boards. A lot of thermal mass on these boards. It can be tempting just to sit there and cook up the part, but not advisable to do that. Sit on it for a couple of seconds and then move it around, start drawing circles, get the heat spread out, sit on it again, move it around, start drawing circles. Just be patient with it. This is a very high thermal mass board and you don't want to damage the component or the traces or the board by blistering it or burning it. One thing that you can do, if it's taking ages to speed up, you can preheat the board, which is one thing that I used to do all the time, but then I got a bit better at with the regular hot air gun. But this board has such a high thermal mass that it's going to be much easier for us to just preheat the whole board to like a slightly hotter temperature, so it's not stealing our heat away. Maybe like 60 degrees, hot enough that you can still do this with it, you know, with your hand, and it will just help massively speed up the removal and resoldering of these components. Okay, that should have built up a little bit of heat in the board. Let's put that down there. So now, removing these parts should be a fair bit quicker. Oh no, my tweezers are quite hot. I obviously got some heat onto the tweezers. There we go, 2 legs are out. Just this last one, pin 1. There we go. So that one's that's out there. So that is Q23 on the good channel. It's other side. Man, there are some really high thermal mass traces here. Holy shit. There we go, right. So let's quickly swap that over while the board's still hot over there. Right. Got my pressure turned up a little bit high. A bit more flux. There we go. And for pin 1, which is the high thermal mass trace, it's connected to the ground plane. I'm going to manually flow that with the regular iron as well. Just because I can do that without preventing sitting on it for ages with the hot air gun, cooking up all the other stuff around it. Okay, there we go. Now Q26 next, which is going to be Q43 on the other side. Holy shit, man, these fucking traces are so thick. There we go. See how quickly that came off after I heated it with the big gun all of a sudden there. It took like 2 seconds just to come straight off the board. There we go. That's so much quicker. The heat just disappears far too quickly though. I'm gonna have to keep on with the big gun every now and then to keep the heat in the board so it's nice and quick like this. There we go, now it's just the 2 above, so Q28. That's nice and easy, nice and quick. No thermal mass. I knew that this one would be fun, that this one would be a challenge. Didn't I say at the start of the stream that these ones from this guy are always a challenge? And lastly, Q27 and Q44. Okay, so that is those 5 transistors swapped around from one channel to the other. So if either any of those are causing the problem, then the issue should have swapped sides, should have swapped channel. So we're going to power it up once it has cooled down and see whether that's actually the case. If not, then we're going to diagnose further. I think if that hasn't changed anything, I'm going to look at some of the transistors around the actual drive IC here. I've actually got a couple of diodes. Got a diode over here, got a couple of transistors here. I'm just going to check diode mode readings on those and compare them to the good channel. And then I might even swap over the drive IC themselves, this IRS 20124S, just in case that the bad side channel is actually sending DC back down from the chip down the input pin to this drive transistor circuit, which is causing it to have DC on there instead. Let's clean off the flux a little bit while it's still warm. Good opportunity to kind of get that cleaned off a little bit before it gets too hard. Okay, cool. Let's give it a minute for that to cool down and just have a little chat with you guys for a minute while that's cooling down. Just going to put an order in for a hot chocolate, I think. How you guys doing? I want to get one for fun after I sell my setup. Yeah, they're definitely fun looking drivers. Those X-Max Ground Zero subs, you know, massive high roll surrounds. Doesn't necessarily mean that they'll move any more or less than other drivers, but they do look kind of cool, right? Okay, I believe that's cooled down enough now. So let's see, has the issue changed sides now that we've swapped all those components around? Interesting to see if it has. I got a funky feeling that it's not going to have. I've got a funky feeling that the issue is still going to be present on the original channel. But let's see. Actually, before I turn it on, I'm just going to reflow a couple of these pads. Just to be absolutely sure that they're soldered, just because the thermal mass is so high on these. Q40 is looking a little bit... Alright. How are you doing? There we go. That's definitely soldered now. Okay. So, if we have PWM still on what was the good channel, then we have probably failed in that little test. Ah, yeah, looks like we do still have PWM on that, so we probably don't have PWM on that. No, we don't. Okay, so yeah, that didn't solve the problem. So I think what we're going to do now is short out the rails just to get rid of any voltage in there. Check some of the remaining transistors around the drive IC over here. Just to compare some readings from the good channel to the bad channel, and then I think we might just do a swap of the drive ICs themselves from one of the good channels to the bad channels, just to see whether this drive IC is in fact faulty. And the reason for doing the swap rather than just dropping a new one in is because this is a drive IC that I have never seen before and I don't have any in stock. So in order to see whether that is actually the problem, we need to swap a known good one from one of the working channels to the bad channel, which is one of the beauties of working on multi-channel amplifiers, is that you often have a version of the circuit that works to compare it to the circuit that doesn't work that you're working on, which is pretty cool. So some transistors over here then. What do we have? We've got Q42, which we've already checked. We've got Q38, Q39 and D30. So let's go ahead and have a look at Q38 first. Got a 607 over here. Now because the board is quite hot now, we might actually get some slight differences in readings between these components where they have different heat on them. So we've got a 608 over here and a, what was that, a 582. So a little different, but like I say, because this is now colder than what's over here, you will get differences when components get hot. They do move in value, so that's fine. Got a 584 that way round. So with the red probe on, I'm just going to move this up a little bit and zoom out. Okay, so with the red probe on the top pin of Q21, which is the good channel, we do have a 554 on one pin and a 574. So let's see if that's the case over here. 585. Yeah, similar enough. Bearing in mind the board is different temperatures. Let's go over to Q39. Got a 618 and a 575. Oh, that's a bit different. Got a 872 there over there. Got a 891. Now that is quite a bit different. More than just the temperature difference would give. Q39, 619, 576, 59, 681. So with the black probe on top, we've got 593 and 682. With the black probe on top, over here, we have 594. There's 69. See that's more like it. 694 and 594-ish. 594, 68. That's more like what I'm expecting to see. They're the same. But when we have the red probe on top, we have 620 and 578, whereas we should have, based on a good channel, values in the 800 region. And let's just confirm that on another good channel. Yeah. Okay. So it's something that's interesting. So what's this connected to? We've got a resistor here. We've got, do we have any continuity to pin 1? We don't. We have continuity to Q38, which was reading fine. Well, now what's on this pin here? Q39 top. We have a capacitor here, C5. Now what does C5 read? C5 reads one way round 418, and the other way round it reads 579, 585. Right, okay, that's fine. That's reading the same as the good channel, so it's not going to be the capacitor or anything like that. I'm thinking to swap over Q39 and swap over Q22. Oh yes, you are an angel. Thank you very much. That sounds good. Oh yeah, thank you very much. Got myself a nice whole chocolate. Check out the mug. Oh, that's mirrored, isn't it? Let's see what on there. There we go. That's a good mug for the stream, isn't it? Let's have a bit of water first though, a bit thirsty. Yeah, let's swap out. Let's just because it's very quick and easy. Let's just swap out these two, just out of interest, because we do have a difference in readings between them, and it's only 2 transistors, so it should be pretty quick. I don't think we've got any high thermal mass traces on these two. They just seem to be going to little vias, so it should be pretty quick, hopefully, to desolder. He says. The board fights back with that thermal mass. Yep, let's get the big gun and cook it up a bit more. That's good. Off you come. There we go. It's hot chocolate, my friend. It's a little bit late for a coffee. If I have a coffee now, I'll struggle to sleep later. Don't you just hate it when stuff gets stuck to your tweezers from the flux? Absolutely hate that. Worst thing. Ah, fuck you! Thank you. Here we go. That's that good. Alright. We're powering it up again then. And I'm going to actually investigate a little further about what voltages are on some of these other transistors while it's powered up. Because I don't think we fixed it yet. I don't think that's going to be the issue. Alright. Bad side. Oh, we need our negative rail reference click back on. Still the same. Yeah, okay. Right, so not really making much progress yet, but we have confirmed that, you know, none of these transistors are bad or anything like that. So what I do want to do is go through each of these transistors and compare what voltages are on each of the pins, just to see if we're lacking any kind of voltage that we should have. So as we've shown, the input to Q23 and Q40 should be PWM, which we have on both sides. Yes. Now pin 2 of the first transistor in line should be negative rail, which it is. Pin 3 should be PWM out, which it is in both these cases, although more so on the bad channel because for some reason it's not being, you know, loaded. So that's one of the main issues there. Q41 pin 1, we just have DC there, and I think that's because we don't have anything into the chip. Oh no, actually, hang on. It's actually correct by the looks of it. So, the next transistor along, we're supposed to have what looks like a few volts, 34, 39, about 5 volts on this second transistor there. So do we have that also over here? Oh, we have way more, we have like 8 volts. Okay, so on the bad channel we have like 8 volts and it comes on instantly. In the good channel we have 5 volts and it also comes on instantly. So there's a difference there. Much more voltage on this one than this one. And that could be just because this channel isn't working over here. None of these voltages are kind of getting pulled on. They're not getting pulled down to where they would be otherwise be. I can't imagine having more voltage would result in having no PWM output from these transistors. Okay, so that's something to bear in mind. Pin 2 of this second transistor, we should have PWM output, which we know that we don't on this one because that's connected to pin 1. I'm actually wondering whether this chip is bad and sending like 8 volts back, which is what's causing this. Interesting. We'll see. So pin 3 we know is meant to be PWM in, which it is. So we do have PWM in there. Q43 we should have. So in this case we've got the same 8 volts there, and on the good channel we have like 3 volts, 4 volts there, and on this one we've got 8 volts, about 8 volts. Pin 2 we've got negative rail, yeah, that's the same, and pin 3 we've got the same 8 volts. And this one we have PWM. Okay, let's check the diode over here, D30. We've got swings down to what's probably 12 volts above negative rail for VCC. and nothing on the other side. This one over here. That's actually this one over here. Oh, hey! Ah, no, that's going to be part of the feedback circuit, isn't it? Yeah, okay. Oh no, not in fact. Okay, that's interesting. That's something a little different. Okay, so D30 over here. Oh, and that's going to be part of the bootstrap though, isn't it? That's going to be the high side. Hang on. No, it's not, because it goes to negative. That's interesting. Okay, so over here we've got this little wee little circuit over here. We've got a diode in a SOT23 package, and on the bad channel, as soon as we hit the remote, pretty much, we get a swing to on the scope. If I pause the scope screen, 27, it's 12 volts. We get a swing to 12 volts above negative rail on D30 up here. So that's going to be like, yeah, that's like 12 volts above negative rail. That's 12 volts VCC, which is what we should have on the VCC pin of the chip. But looking down at one of the good channels down here, I don't think we have that, unless I just didn't touch my probe on it properly. Nope. Maybe it's like an enable signal? No, okay. That is actually PWM, which is interesting. Oh, maybe that's like the low side out or something. Let's just check the low side. We've got over here. Low side. Right. Now that is interesting. What is that exactly? So that does turn into PWM. Supposed to turn into PWM when the amp activates. Right, okay, I'm going to go ahead and trace around there now and see what that's actually connected to on the good channel, and have a poke around there, because that doesn't seem right at all. Over on this side, we have this little diode, D31. One side of it, when the amplifier activates, has the output switching wave from the low side drain, has the PWM and the output from the MOSFET on it, and on the other side doesn't have anything. On the bad channel, we have, as soon as you apply the remote, we get about 12 volts above negative rail on that side of the diode. That isn't present on the MOSFETs yet or anything like that, so I'm wondering what's going on right there. Okay, let's drain the rail caps from this amplifier by shorting out the rectifiers here to get rid of both positive and negative rail. And let's turn our attention then to this area around here. Now I want to take a quick look at D31. These diodes are known to fail, so let's just make sure we don't have that shorted. We have climbing value one way round, which suggests that we are charging a capacitor of some sort, and the other way round we have a 380-ish, 385. Let's check that over on the good channel down here. Got a charging capacitor, similarly one way round, and the other way around we have a 380-ish. Okay, cool. Let's just check these capacitors. On the good channel, obviously they're fine. Over here, it's fine. Okay, the diode, one way round, we have a 498. Flip the probes, diode mode. We shouldn't have anything, probably. No voltage drop the other way around. So we had a 498 one way round, flip the probes. Got a 534, a little different. A bit of a difference there. Although actually this is climbing, because the board is quite hot around here. So if I spray some isopropyl alcohol, very useful, and blow on the board to evaporate the isopropyl alcohol, which will remove some heat from the board, we might find that that value has now risen. 510, yeah, we're getting closer. 530, yeah, the board is a bit different temperature over here and over here, so that's fine. So what is that connected to then? What is that connected to? D30 got connected to these capacitors here. Are we connected to anything else? We are connected to the drive IC. Pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pin 12 of the drive IC we're connected to, which I think was it was the part of the bootstrap supply, wasn't it? Let's have a look. Pin 12 VB, yes. High side floating supply. So that just jumps straight to 12 volts negative rail. That is further making me believe that the drive chip might be faulty. We shouldn't get negative 12 volts on the high side floating supply out of nowhere. Hang on a minute. What pin was VCC? VCC is pin 8, which is 12 volts above negative rail. So maybe VCC is shorted to VB. It's not, but we have a 5033 one-way round. Aha, interesting. I wonder actually whether this diode D30 is leaking. It still reads okay on the multimeter, but we do have VCC going through this diode to VB. So if this diode is leaking slightly inside, it may be leaking voltage from VCC, which is 12 volts above negative rail and will immediately appear as soon as you hit the remote. I wonder if it's leaking through this diode to VB, which is what's causing the issue. Okay, that's an interesting concept. It doesn't read bad, but it could be bad. So we're going to go ahead and remove it. So at this point, it's either going to be that it's... At this point, the issue is either going to be this diode or the drive chip itself. So the easier thing to remove is the diode, so we're going to do that first. How many people are actually following this and understanding what I'm doing, and how many people are just enjoying it for the vibes and the chat? What do you reckon the M4A is capable of at 1 ohm? I can't actually remember what the power rating is on the M4A. That's bad, but I can't actually remember what the power rating of it is. Is it meant to be like a 5K or something, or 7K? I can't remember. But there's dyno videos of it online. Just go to YouTube, type in M4A dyno, and I'm sure you'll be able to find what it does at 1 ohm. Most of you guys are like, nope, no idea what you're doing, just enjoy watching your work and here for the vibes. Fair play, man, fair play, guys. I appreciate that. That you know what that says to me? That says to me that the fact that you're not necessarily understanding what I'm doing, but you're still vibing, that's cool. I appreciate that. That says to me that you're enjoying the company, enjoying the chats, a little bit of advice here and there. Alright then, if a lot of you guys aren't necessarily here for to understand exactly what it is I'm doing, let's have some chats. What do you want to chat about? Give me some questions. Let's do some Q&A. Fire all of your questions. Anything you've ever been a little bit curious about. Anything you've ever, with audio that you've ever been like, it's a bit weird. I wonder how that works. Or like, I haven't really seen that before. Or like, maybe stuff about box rise, maybe stuff about rotary woofers, or just, I don't know. Let's have some back and forth going on in the live chat. Let's get some Q&A going on. While I solder this diode to the tester. It'd be really nice if it was this diode that's the problem. I've got a sneaky suspicion that it's the actual drive IC itself. Straight up kick ya in the nuts. Jumped in a few minutes ago trying to catch up. Just a real quick TDDLR. That's not the correct. TLDR. Quick TLDR for anyone that's recently jumped in. Rockford Power T800 T1000/4. We have 4channel amplifier class D. We have one channel that is faulty. It is not dead output MOSFETs. It's a drive circuit fault. When you power the amplifier up, the channel swings to negative rail immediately. So you get negative DC rail voltage on the speaker terminal for that channel. So we've been tracing back to see why that is. We found the drive circuit on the back of this PCB, which is a strange driver that I haven't really seen before. It is an IRS 20124S drive IC. And we've traced back to find that this drive IC isn't actually being fed with PWM into the input pin. It's being fed with straight DC into the input pin, hence why it's passing DC. It's telling the low side MOSFET to turn on all constantly, hence why we've got DC on the output. So we're trying to work out why we don't have PWM on pin 1. We found that we do have PWM coming from the main kind of PWM generation board for this channel, which is this board right here on the end. This is going to be creating the pulses for the channel, for the driver. We do actually have pulses coming out of this drive board, but it's not making its way to the chip. It loses it at Q41 just here. If I jump in on this one here, so the PWM pulses come from this pin here. They go into Q40, go into Q41, and then they get lost. They don't come out of Q41 at all. And I've just found out that we have a diode over here, D30, which it sits between the VCC, the voltage supply input of the chip, and the high side floating supply, the VB or VS, whatever it's called, I can't remember, but the high side floating supply for the bootstrap for the high side. It sits between these two, and this diode actually has 12 volts reference to negative rail on the VB or VS. Let me just get it right. Let me get it right. On VB, it has 12 volts, negative 12 volts negative rail on VB. That should never be there when you turn the amplifier on, which suggests that there is either voltage leaking through from VCC through the diode to VB, or it's happening inside the chip and the chip is leaking and damaged internally. So I just removed the diode, as you can see here. I got it on my transistor tester, so we're just about to find out whether this thing is a diode or whether it's damaged and it's just leaking both ways. Well, shit me, it is a diode. If this was damaged, if it was allowing current to pass in both directions, then it would not read as that. So what I can do now to just prove that is, with the diode removed, I can go ahead and like start powering the amplifier up. I'm not actually going to let it fully power up, but if we still have that negative 12 volts ref negative rail on the pad of the diode that was in there, then we know that it's the chip. We know that it's the chip that's bad. Yep, there it is. Still there. So it's the chip. It is the chip. It was the chip all along. Even though right at the start of the stream I was saying, I don't think it's the chip, because if it was the chip it would probably turn in both FETs on at the same time. But in this case, sounds like the chip has failed in a very interesting minor way, perhaps. But let's not get our hopes up just yet that we found the culprit, because we do need to remove the chip first and just make sure that that has gone away. So if we remove the chip, we can actually swap, because these are random. These are strange drive ICs that I don't have in stock. I've never used these before. So what I can do is I can swap one from the good channel with the bad channel and see if the bad channel starts working all of a sudden, just to confirm that, and then I'll need to obviously order a new one. So let's put the diode back on before I lose it. And Joseph, holy shit, thanks for the 20 bucks, my friend. That's quite a lot of money to give a random guy on the internet. So cheers, buddy, appreciate that. That's very awesome of you. Were you ever able to figure out what was wrong with the driver cards I sent you a while back? Shit, hang on, let me just finish my hot chocolate. What did you send me some? Did you send me some of these? Some of these this style of driver card. If you did, then I haven't gone through the ones that you sent me, because actually, since you've sent those to me, I don't even think I've had an amplifier come in for a repair that uses that drive circuit. So I haven't actually been able to power them up. So the easy answer is no, I haven't been given the opportunity to just yet. Man, that was a freaking good hot chocolate, that was. Do love me a hot chocolate. I am a chocolate pixie, I swear. I absolutely love chocolate, my man. But Joseph, thanks so much for the 20, and again, thanks for sending those driver cards over, because they're so useful to have around as spares anyway. yeah, I don't have any information on what was actually wrong with them, because I haven't had a chance to really do anything with them yet. Alright, let's put the diode back in. Okay, cool, diode's in. So now I want to go ahead and remove the drive IC, but because I know that this board is so high thermal mass, let's go ahead and blast it with the big heat gun first. And Mike, fucking hell, thanks for the 20, my dude. This is where I pick your brain. What do you think may have caused that chip to fail? So, as we can tell, because neither of those MOSFETs are dead, okay, this amplifier hasn't been abused. It hasn't been, the speaker terminals haven't been shorted out. We haven't had low resistance on the we haven't had low resistance speaker connected. We haven't had a speaker die. We haven't had it, like, the MOSFETs are fine. The MOSFETs are the things that are connected to the speaker terminal. They're fine. So the FETs haven't failed, and the FETs are the first thing to fail with abuse, or if you do something wrong, wire the amp up wrong. These chips, they're like such intricate silicon printed onto like a silicon wafer inside the chip, and they are run probably quite hard in these environments. They get quite hot. They go through quite extreme temperature changes. When this is in the winter time, this is left out in the car in maybe like -5 degrees Celsius in some parts of the country, or like -1, and then you fire the amp up and this chip will immediately rise to operating temperature, perhaps 40, 50 or even 60 degrees Celsius in very little time, from like 0 degrees up to 60 very quickly, and then when you power off again it will cool down quite quickly again as the car is outside. So it goes through big fluctuations in temperature, and the electronics, well, actually everything hates that. Like, stuff doesn't like heat cool cycles, and electronics hate heat cool cycles, and it's one of the biggest killers of silicon semiconductor components, chips, transistors, diodes, computer components as well. You'll find this is the case that in massive server houses around the world, you'll have servers that are powered on 24/7, 365 days a year, and they work all the time. They just work and they work and they work and they work. And then one time an engineer needs to shut down that server to perform some maintenance, to swap out some hard drives or do something with it. And then when they shut it down, it was working fine. Then they go to power it back up again and it doesn't work. It's got a problem. There's an issue. There's a hardware failure. Something's wrong. It wasn't there before they powered it down. And that's happened because the server has powered down. It's got chance to cool down. That silicon that's been running hard and long all that time, while it's powered off and it's cooled down, it may have, like, the crystallines have slightly changed their shape, or they've slightly failed in some way. Cracks have formed in the solder. Something has happened while it's cooled down and turned off and then got powered back up again, that's now caused it to fail. So you'll see this time and time again. Stuff hates power cycles and stuff hates heat core cycles. So with a chip like this, with how hard it's run and the temperature changes that are present in a colder environment, it's probably what's killed it. Just bad luck. It happens. Yeah, Jerry says, this is a discontinued chip. Yes, it might be quite hard to find a replacement. However, I imagine that even if this chip is discontinued, we can't find a replacement, I might be able to find a suitable alternative, perhaps, that has the same pinout and the same operation. This does have the overcurrent protection built in, which I haven't seen as much, but we'll go digging, we'll go looking. Once we've confirmed that this is actually the problem, we'll go digging. Okay, that should be enough. It's pretty powerful, that big gun actually. Holy shit, man, even after all that, it's still taking its time. Jesus. Right, let's turn the pressure up a bit, let's turn the temperature up a bit. Come on, you bastard. You're coming off here if it takes a month or some days. There we go, that's 1/2 off. Just need a bit more pressure, that's all. Wait. There it is. Alright, we are off with the chip. Now, I don't have any way of testing the chip. You can't whack this in a transistor tester or a chip tester or anything like that. So all we can do is, now that the chip is removed, okay, so the final component that drives the MOSFETs has been removed. Very important tip to remember. If you are doing this, if you're interested in amplifier, if you're doing this, if you remove the last component that drives the MOSFETs, or you remove the gate resistors but the MOSFETs are still in the board, you must absolutely always check that the MOSFETs have some resistance, some continuity of some kind between gate and source, legs 1 and 3. Because if basically the gate is so sensitive, electrons and charge, even just from the air particles, can find their way onto the gate and turn the MOSFET on fully when you don't want it to, when it's powered up with voltage. So sometimes the MOSFETs will rely on the components inside the chip to pull the gate down to ground and prevent that from happening. And if you remove the driver, then you remove that safety net, and you can actually have the MOSFET randomly explode for seemingly no reason when you remove the driver. So I just want to make sure that we still do have some kind of pull down. Shit, I don't think we do. I think it was relying on the chip. So yeah, this is a prime example of why this is important. So you see how here I've got the multimeter set to 2 mega ohms. 2 mega ohms. That is very sensitive to the point where it can read the resistance through my body. See that? So that's how sensitive the multimeter is right now, and we don't even have a reading on the multimeter screen between the gate and the source. So clearly, if we go and turn the amplifier on now and we put like 80 volts on the pins of these MOSFETs, some electrons are going to find their way onto the MOSFET gate, and the MOSFET is going to turn on all by itself and explode. So in order to prevent that from happening, all we need to do is short out gate to source, which will prevent that from happening. So you just take some old component legs, bend them over a little bit, and just create continuity between gate and source, which will prevent the MOSFET from ever turning on. And this is fine to do because we've removed the driver, so there's going to be nothing is currently connected to the gate pin. The gate pin is currently floating all by itself. Nothing's connected to that. It's not grounded in any way. It's not connected to any part of the circuit. And we want to just ground it out so that it has no chance of turning on by itself or stealing some electrons from the air around it. And the reason I'm doing this is because I just want to double check, I want to make sure that we don't have the 12 volts reference negative rail on the pad for VB, I think it was, now that we've removed the drive chip. We shouldn't do, because it was either coming from that diode or it was coming from the chip. So we removed the diode was fine, so it's got to be the chip, right? Holy shit, these traces are so high thermal mass, my man. Even the gate leg is so high thermal mass. What the fuck? These are probably some of the worst boards to learn on as a beginner until you get used to like heat transfer and you kind of learn it a bit, and until you get decent equipment. Like, fuck me, trying to work on this board with like a 30-watt Walmart soldering iron would just be absolute torture. You would not have a good day. Right. Was there any questions in the chat? Bevis, what do you use for lighting when you're filming YouTube? Interesting question. I actually answered that in a video that I'm making at the moment. It's going to be released probably next week. So when you're in the workshop, okay, it's very important to have, when you're working amplifiers, or actually doing anything, that doesn't have to be amplifiers, can be doing anything. When you're doing anything that requires you to really see what you're doing, you need a lot of light, but most importantly, it must be diffused light, okay? You would think, oh, if I need a lot of light, let's just get a really fucking bright lamp or bulb or like bright floodlight and like point it at the thing that I'm doing. Which is no good, because your hand, as you move your hand over the board or whatever it is you're working on, or as you move your head over the board, you cast a shadow, and it then suddenly creates a massive dark spot on the board that you now can't see anymore because you put it into shadow, or like you lean over and all of a sudden your head blocks out the light and you can't see it anymore. So you want the light to be as diffused as possible so that it's coming from all directions. Like if you look at the board here, I don't know if you can really tell, but like there's a reflection in the board, but my hand doesn't cast a shadow. Like it doesn't really cast a shadow anywhere. Like a little bit maybe, but like wherever I move my head, I've still got lots and lots of light around all the parts of the board there that I can see. And the reason for that is I've got these very powerful LED spot lamps up here, and they're pointing at the ceiling, and the ceiling is painted white, and so the light just bounces all around the room, all of the ceiling down onto the board, and it makes a huge difference. It's very, very bright in here. The cameras don't really make it look so bright, I don't think, because they, you know, auto exposure, they sort the brightness out and make it look normal, but it is very bright in here. And yeah, you want diffused light. Would you invest in better tools after working on this amp? I'm not sure. I'm not sure what better tools would help. Like a more powerful. Well, no. So the hot air gun, doesn't matter how powerful the hot air gun is. That's not going to help with getting these transistors off the board with the hot air gun. Like your hot air gun could be 1,000 watts, but it's still going to pump out the same temperature air. And the issue with this amp being such high thermal mass is it just steals the heat away. So the only way to stop that from happening is to get the board up to temperature with a really big powerful gun first, and then start attacking each individual component. My soldering iron is actually less powerful than what I would recommend someone start out with. I think my soldering iron is something like 60 watts, and I wouldn't recommend anything under 80 watts. But I do have, for the times when it is necessary, I have a 200 watt freaking beast here for doing large traces, transformers, terminals, inductors, stuff like that, and the bigger MOSFET packages. So I have lots of soldering iron power here when I need it, but obviously look at the size of that tip. Can't do any of that intricate work here. So yeah, it would be nice to have a more powerful regular iron for sure. That's something that I might invest in, but I can work with what I've got. It's fine. Would you ever consider repairing an underseat subwoofer? Do you live in the UK? I don't know, maybe. It'll have, if it's an active unit, it'll have obviously an amplifier built in. I could check it out maybe, see what's up with it, but aren't those things usually pretty cheap? You might just be best off buying a new one or something else rather than paying for a repair. Super question, where is the wattage generated, and is that something you could technically upgrade to make more wattage, or is it just a balance between input, drive circuits, FETs and output side? So in the amplifier, so the thing that makes an amplifier do a certain amount of power, okay, there's two things, okay? Obviously, a speaker is just dumb. It's just going to react to whatever voltage you send to the voice coil. The higher the voltage you send to the voice coil, the more it's going to move. So what makes an amplifier more powerful is simply it outputs more voltage, the voltage of the output sine wave is higher before clipping. Clipping is just when the amplifier runs out of voltage. You know, you're asking the sine wave to be generated beyond what the rail voltages in the amplifier are. So the higher the voltage in the amplifier, the more power it has the ability to send to the subwoofer. However, as you go up in voltage, the components that you can use in an amplifier start becoming their ability to pass current becomes less. So yeah, like I could take a 2000 watt amplifier and I could double the internal rail voltage of it by rewinding the transformer. And I could replace all of the components in the amplifier for components that could handle that higher voltage instead, like better caps that were higher voltage. So I can increase all the components in the amplifier to deal with the higher voltage that I've now got. So now the amplifier can send twice the voltage to the subwoofer than it could before. Therefore, more power, right? Yes and no. Because now that the amplifier has the ability to send twice the voltage to the amplifier, there's going to be twice the amount of power across the board and across all the components. So not only do you have to change the components to deal with the higher voltage, but you also have to change the components to deal with the extra current that's going to be passed through them as a result of the extra power. Yeah? So upgrading an amplifier to do more power, you have to change the power supply FETs for higher current power supply FETs because there's going to be a lot more demand through them. You've got to rewind the transformers so that they actually output more voltage onto the amplifier stage. You have to change the rail caps to higher voltage rail caps. You have to change the output MOSFETs to higher voltage output MOSFETs. You have to modify the drive circuit to deal with the higher voltage. You have to beef up the traces. You have to change the output inductor to not heat soak from the added current. The transformers, you might even have to make them bigger or change the wind ratios so that they don't saturate from the extra current. You have to do so much that you're better off just selling it and buying a bigger amplifier in the first place. Like, trying to modify an amplifier to do more power is more effort than it's worth. And I get this question all the time. Oh, hey Sam, if I send you this amplifier, can you upgrade it to do more power? Yes, I can, maybe. It won't be as reliable as just buying a bigger amplifier, and it'll be more expensive than just buying a bigger amplifier in the first place. So it's pointless. It is absolutely pointless. Just buy a bigger amp in the first place. Yeah, exactly. And then Jeremy says, now you need a bigger heatsink. Yes, absolutely. If you do all that and you do manage to get the amplifier able to deal with double the power, it has to now get rid of double the heat. And if you're in the stock heatsink, then it's just going to saturate the heatsink, and you're going to have to add fans. Yeah, it's just stupid. You're just moving the goalpost. You know, you change a part, and now the limit is this next bit, now this next bit, and this next bit, and by the end of it, you just buy a bigger amp. What am I doing? Yes, okay, cool. So we have jumped over the output MOSFETs so that they're not going to explode by themselves. So we just want to power this on a little bit just to check that we don't still have 12 volts reference negative rail on D30, which is the VB, the high side floating input. Let's just have a look. So I want to get a reference for negative rail hooked back up on channel 2, which is that one there. So if we probe D30, yay! No more 12 volts ref negative rail. So it's definitely probably going to be the chip. And the way to confirm that it was definitely the chip is going to be to swap. So just to confirm that that is definitely the issue, we're going to take one of the chips from the good working channel, we're going to put it in the bad channel and see whether the bad channel now starts working. So let's get rid of the rail voltage in the amp by shorting out the rails. Like this, turn off the power supply. I'm going to have to reheat the board because it will have cooled down too much now. What is the nominal voltage at ULK? I think you mean, say in the UK we have 240 volts AC coming out of the mains. 240 volts AC. Let's add some flux to that, and that one as well. Oh, hey, one last thing we could have checked, which I didn't check. The board's kind of hot now, so I don't really feel like want to power it. But I could actually have probed pin 1, pad 1 of this over here, just to see whether we had PWM. That's actually a really stupid test that I should have done just now. Let's just do that real quick. Yeah. There's PWM there at pin 1 now. So yeah, definitely is the chip. Definitely is the chip. I'm just going to prove it by swapping over the chip from the good channel to the bad channel, and then we'll go searching online for a replacement. So actually I'm going to answer Taloko16's question, and the answer is yes. Very easy to do. You don't need to modify the amplitude to do that. I'm going to answer that once I've done this. Hang on. Just let me get this chip swapped over, because while this board is hot, because it cools down really quickly. There we go, she's off. And quickly put it in place of the bad channel. Get it lined up. I need to apply some more flux, because I haven't put any fresh solder on the pads, so loads and loads of flux. There we go. It's not dead center, but it is connected to all of the pins correctly. Like, I'm a bit of a perfectionist when it comes to getting these things back on. As you can see, that it's like ever so slightly skew with on one side. I'm not happy with that, but I wasn't happy with the amount of heat I was applying, so I'm just gonna let it cool down. It is soldered. I'm gonna test it like that, and then if that is the case, if this channel now works fine, which I think it probably will do, or I'm gonna need to swap out these little jumpers. I need to not put those on there anymore. I need to put those onto the channel I just removed the drive IC from. So let's just do that real quick. And then yeah, if it is the chip that's the issue, we're going to see if we can order a new one or a replacement. And then if we can, obviously I'm just going to reflow this chip to get it get a bit more center, because yeah, I would not be happy with letting it leave the shop like that. Even though it might work fine, it just looks a bit skanky. Swap this over to the other channel so that this one doesn't explode. Gonna have to put some fresh 6040 on that. Oh yeah, so in answer to that guy's question, can you take two amplifiers that are not normally strappable or linkable and make them strappable or linkable and link them together? Very easy. I did this many years ago with an old Technics SUV 5, what the fuck was it? Technics SUV 550, I think it was. yes, very, very easy to do. All you need to do is you need to flip the polarity of one of the amplifier signals. So hopefully the amplifier will have a phase dial. So you need to set it to 180 degrees exactly, and you would ideally want to confirm that with an oscilloscope because sometimes the phase adjustment circuits are not exactly accurate based on their markings. So you want to grab an oscilloscope and you want to get one of the amps 180 degrees out of phase with the other amp. And you can't just flip the polarity of the speaker terminals or anything like that, or you can't just take the RCA and like flip the wires around in the RCA. It doesn't work like that. You have to actually flip the polarity of the signal itself, which you can do in amplifiers that have a phase adjustment circuit. So yeah, get the polarity of one of the amplifiers flipped, and then all you have to do is gain match them exactly. So with a multimeter or an oscilloscope, gain match the amplifiers exactly to the same output voltage, and then you connect your speaker between the two positive outputs of each amplifier. So you connect the one wire from the speaker to one amplifier positive, and the other wire from the speaker to the other amplifier positive. You connect the wires to both positives of each amplifier, and the speaker will see the potential difference between the two amplifiers in bridge mode. And yeah, that's basically it. Bearing in mind that obviously take into account that the impedance will be different, the final impedance will be different between the amplifiers. So if they're 1 ohm stable each, then you can connect a 2 ohm load between the two amplifiers in strat mode. Okay, let's just check that all of these pins soldered correctly and none of them are loose, even though the chip is a little bit skew with. They are all soldered nicely. Sorry about my head being in the way there. Okay, cool. So that is the chip from the good channel on the original bad channel, and the good channel has the chip removed with the safety jumpers on the MOSFET so they don't explode. So let's power it up and see whether the bad channel now works with the chip from the good side. So low side MOSFET is this one here. Let's get a reference for negative rail hooked up. Okay, we don't actually have anything on there at all. We have switching on 2 of the channels. Nothing on this one yet though. It's interesting. Okay. Do we have PWM inputs? We have PWM input. We don't have anything out, and it could just be that the channel needs a bit of a kickstart through the RCAs, which is actually the case for the others. They needed a bit of a kickstart through the RCAs. It could just be that it's a bit too hot because we just finished soldering. So I'm going to get some RCA signal and just plumb it through, just to kind of see if we can kickstart that channel. It does happen sometimes. Remote input. We have which channel is it? I think it's front left. Is the one that's the issue. So front left input is this bottom RCA input here. No, don't have anything still. So it's not swinging to negative rail anymore, but it's not actually giving us, it's not actually building anything. The chip is receiving pulses in to the chip, So it must just be that the chip is in shutdown or not receiving bootstrap like a feedback. Let's just check that the chip has VCC. Yep, the chip has VCC. VS is, sorry, VB I think it is correct. Have input pulses. Now, do the input pulses change with the RCA signal that I'm feeding in? Could be that we just got an input, a preamp circuit fault as well. Let's go in there. VC couple. Okay, so those pulses that I'm sending aren't actually changing with my RCA input signal. So maybe it's just that that's not actually sending any signal to the RCA. So we have RCA signal going in, as you can see. Let's just check that on another channel. Let's plug this RCA into. Maybe I got that wrong. Maybe it's front right. No, it's not front right. I'm going to plug the RCA into a different channel just there and try again. So I think I've just plugged it into the channel that I removed the chip from. So let's take a peek at the PWM going into this one. Yeah, so that is changing with my RCA signal. You can see that there on the scope screen. That's changing PWM with my RCA signal. Yep. So if I now go into one of the rear input, we should be able to see that affect the MOSFET output. This one here perhaps. Yep, there we go. So yeah, that's changing the PWM of that channel as intended. So why is that not changing the PWM signal of our originally bad channel then? Has it killed something along the way perhaps? Is there actually a problem on the drive board itself? Oh, it is doing something. I'll zoom in there. Yeah, like when I increase the RCA signal, it is doing something. Okay, is the chip in shutdown? Is the chip in shutdown? Let's have a look. Shutdown was pin number... it is pin 3, and it said when pin 3 was at ground, the chip will be in shutdown, didn't it? Let's just check that. OC... Can't remember where it said that. Here we go, reference com. Shutdown LO and HO when tied to com. So when DT-SD is at 0, then the chip will be in shutdown. And that is pin number... what is it? 3. So it's pro pin 3. What the heck do we have on there? Okay, we have negative rail, so that is in shutdown. Let's check what we have on a working channel, pin 3. That jumps up, yeah, when the channel is active, that jumps up. but it only jumps up when there's like jumps up there. So I'm just checking pin 3 of like a remaining working channel here. Boop. Jumps up after a certain amount of time. Boop. Okay, let's check it on the one that we removed the chip from, because that would be interesting to see what happens when there's no chip in place with the shutdown. Boop. Okay, yes, that does come up. So on the one that's not working, what happens? Ah, yeah, nothing. It doesn't come out of shutdown. So maybe some other fault then with the shutdown. Why is it not coming out of shutdown? Okay. New problem then. New problem. Why is it not coming out of shutdown? You see that there? You see that? Do you see how all the other ones came out of shutdown, but that our bad one didn't? So what is the pin 3 connected to? Q38. And also R132 and also Q39. Didn't I say that? I noticed like an issue around here before. Didn't I say that? I noticed there was like a weird issue around here. Like where the multimeter readings were like all wrong and different, right? Just checking we don't have a short to ground to negative rail on here. Okay, let's power it back up and let's see where the shutdown signal comes from. So on a good working channel, which is going to be one down here somewhere. Let's take this channel without the drive IC. So we have the output to the shutdown pin is here. So it goes down and then it comes up. Boop, like that. Okay, so we have down, pin 3, boop, comes up as well. Pin 2 is okay, so it comes in via pin 3. And we've got this resistor here, which is going to be feeding it as well. On one side, okay, so it doesn't come through the resistor, it comes from there and onto here, and there, and there. Okay, so let's check over here. Okay, we have the correct voltage there, not there, not there. So maybe Q39 is bad. That would be a bit strange though. Maybe it's coming from the chip. Okay, let's remove the chip again because it feels like it's coming from the chip. Maybe these chips are incredibly sensitive to heat, so while desoldering it and resoldering it over there, we may have like screwed up part of the silicon inside. It is possible. These chips can be very, very sensitive to heat. So we're going to remove the chip and we're going to see whether we get the normal shutdown signal on the pads with the chip removed, just to kind of confirm, because it does seem a bit weird. And the best thing might be to do is now to just buy like a few of these chips. I might actually even just replace all 4 of them. If we can buy these chips, to buy 4 replacements and just replace all 4 of these, because maybe they're on their way out, because one died, maybe the others might be on their way out as well. It'd be good practice to replace all 4 of them and just solder them on manually with the soldering line, so that we're not cooking up the chip with the hot air gun. So what we need to do is we need to remove all of the excessive solder from these pads that's on there once we've removed the chip, and then place the new chip in place and blob solder by hand with some good flux the pins, so that we're not cooking the chip up with the hot air. can't get my tweezer down the side of it. This diode's in the way. Super fucking frustrating. I'm gonna pull that diode out of the way. It's massively in the way. I'm just going to get this diode slightly shifted over so I can actually get my tweezers around the chip to pull it out. It's really annoying. Come on. Come off nice and easy. God, everything is just so well... nothing will take any heat on this board. It just soaks it away. Yeah, I can see that I've already bent pin one. Fuck this, man. Right. Board is acceptably hot. It will work fine. Okay, let's check to see whether we have the correct shutdown signal on pin 3 with the chip removed then. Shit, we don't. So the chip's probably fine. Oh, fuck's sake, I've just bloody removed it for no reason. I was genuinely believing that... Whoa, okay, a lot of current just got drawn there. I don't know if you noticed that from the power supply, but a lot of current just got drawn from there. From the amplifier, could because it's hot. Oh, I'll tell you why a lot of current just got drawn. I've just removed the drive chip and I haven't bridged over these MOSFETs. So that is exactly the issue that can happen. I just powered the board up with the MOSFETs with no driver, and the gate leg is just floating. It's not connected to anything. So therefore electrons found their way onto the gate and the MOSFETs turned on. So I may have killed the output MOSFETs here. Let's just have a quick look. Nope, they're fine. But yeah, those MOSFETs did just turn on. One of them at least just turned on because it just drew a bunch of current, and so we just need to go ahead and quickly remember to bridge over these while we are pissing around, turning the amplifier on and off. So why are we not getting the shutdown release signal to these sets of pads then? So it's not the chip. But I think we know that we're going to need a new chip anyway. So maybe, why don't we just look online and see if we can get some new chips for this first anyway, just for a bit of fun. because if we can't get new chips for this, then it's going to be a bit of a pain in the ass to repair anyway. Try and find a replacement chips from somewhere. Okay, let's just power it back up again and see if we get the shutdown signal. So this chip will be being told to shut down, but the other chip, the good side, is being told to power on. So yeah, we do have a difference. We have an issue here with like Q39 perhaps. So Q39, let's have a look over here. That's correct. So the signal coming in, boop, should be on Q39 pins 1 and 3. Boop, which is not. So let's go over to this channel, this side. It's not there at all. So yeah, we're gonna have to diagnose something around here that's telling this chip to not to stay in shutdown, which is going to be part of this circuit Q39. Something funky around here, but it'll be something that's feeding Q39. That's causing that. I might actually go ahead and just quickly remove Q39 just to see where that's coming from. Well, actually no, fuck it. Let's not remove Q39. Let's just do a bit of research over here. What's Q39 connected to? So it's going to be this one here. What's this connected to? What are you supposed to be connected to? It goes through a via. Q21. No, that's actually connected. I just realised that my multimeter cam is spazzing out, so just bear with me a sec while I sort that out. Yeah, I don't think Q39 isn't actually the problem, because we swapped Q39 from the good channel and the bad channel. I don't think that's the problem. Let me just quickly fix my multimeter cam. It's got a deactivate, reactivate. There we go. So these transistors are actually connected together from the good channel and the bad channel. We got that one there connected. That one there connected. So it's probably going to be like positive and negative supply, like a pair of drive transistors essentially. So the signal to turn on and off is probably going to come through from these. Now I just need to find what these are connected to. Looks like it goes off through a via to the top of the PCB. It will go to somewhere else. Goes off through here. There's a little via here that goes off to the top of the board. I might try and find where it goes to. I don't necessarily think it goes anywhere over here. It might actually go to the driver card itself. It might go to the driver card itself, hey? Yeah, it does. It goes to the driver card. Oh shit, so we might actually have an issue on the driver card in the end. So that's there. Yeah, that goes off to the driver card. Okay, shit. So it looks like something on the driver card itself might have actually failed. Right, okay, let's flip the board over and have a look. So that is this second pin here. We're not getting a signal there. Yeah, fuck. Okay. Might just remove Q39 and Q38 just so that there's no components kind of in the way, because I don't want to have to remove this driver card unnecessarily, so I'm just going to go ahead and remove these two just in case. That's Q39. Come on, off you come. That's Q38. Alright. Q39, Q38 removed. So now we just want to see whether the activate signal comes from the driver card and is now present, because maybe these transistors, one of them was bad perhaps and was pulling it down. So the activate signal is coming from this second to last pin here on the driver card. So let's go ahead and probe that. It's a bit slippy, a bit scared. I might probe the pin of the transistor instead. Is it going to activate? No, it doesn't. It goes to ground. So I think the issue does come from the drive card. I'm just checking the good working channel. Boop! Yep, that comes up. And let's do this one again. This bad one. Oh shit, the board is freaking hot. Yep. Nah, it is not happy. It doesn't come. It doesn't arrive. It does not arrive from said driver card. Okay, so we're gonna have to do some work on the drive card then, perhaps. Looks a bit. Yeah. Right, so we know it's not either of these transistors that's the issue, so while the board is still hot, let's solder them back in place while the board is nice and hot, because it's a pain in the ass when the board cools down. I'm going to put some fresh solder there. Putting some fresh solder on these pads just to make the resoldering a little bit easier. Oh yeah, that fresh solder helps a lot. There we go. And second one. Right, there we go. Okay, fuck me. So, shit, I guess we've got to remove these driver cards now. Let's just see if we can access them from being in the board. Access that pin. So that is the second pin from second pin up, which turns into the second pin in. Is that that's the one on the far? So that's going to be the bottom pin there, I guess. Trying to work out which pin it is from the bottom to the top. So it is that one there, I think. So which pin are you on top? Bottom one there. Okay, cool. So let's have a look at this then down here. Maybe give you this camera. Try and get this held up somehow by something. Like that. There we go. So second pin down low. What do you connect to? See if I can do this without having to remove it. Any transistors perhaps in there? Fuck. I think we're going to have to just remove it. Ah, yeah. Some transistors down here behind the inductor. Yeah, fuck it. I'll remove it. A sensible thing might be to actually, again, like I say, we've got working channel example here. So the sensible thing might be to go ahead and what is this? Is that the bad one? Is this the good one? Yeah. The sensible thing might be to swap one of the driver cards from the good channel with one in the bad channel, just to confirm, just so we're not like diving down the rabbit hole that's not actually the case. Remove one of each driver card and then we can compare readings between them when they're off the board, just to kind of see what's going on. And then we can also put the driver card from the good channel in the bad channel, just to see whether that fixes that problem there. Make sure the issue isn't actually on the board. So yeah, this is going to be fun, removing these driver cards. Such a high thermal mass board, but we have my massive 200 watt soldering iron, which is going to come massively in handy for this. This is the exact time that you want to use something like this. Massive soldering iron with huge thermal mass. We want to absolutely flood these pins with solder. We want to grab the board from the underside here, grab the driver card like this, and we're going to very gently wiggle it out. So we're going to melt all of these solder like here with this iron, pull it out slightly by like a millimeter, go and do the same on this side, pull it out slightly by a millimeter, and we're just going to walk it out like that with the solder completely melted each time that we do that. That's going to be the best way that we keep the vias intact and the traces intact, etc. I'm just going to go ahead and make sure before I do that that there isn't anything else connected to this pin here, just in case there's any other components on the board here that we could that might be the culprit, to save us having to pull the drive card out just yet. I think it's probably not. I think it's just a straight signal to Q39, Q38 through there to pin 3. I just want to make absolutely sure. Oh wait, what's that? Pin 1, 2. Oh, hang on a minute. 1, 2, 3, 4, 5. What's pin 5? Pin 5 is OC over current. Eh? Why have we got continuity between pin 3 and pin 5. Should that be there? Is that by design? Hang on, we don't. What? No. Pin... Okay. Pin 5 is connected to the output pin from the driver card. Is that by design? Let's check the other channel that was fine. 1, 2, 3, 4, 5. Okay, that does seem to be by design. Okay. I guess that makes a little bit of sense actually. Fuck it, I don't know. Does it? So, okay, overcurrent. So that, yeah, that does sort of make sense. If overcurrent trips, then overcurrent, I think, is an output from the chip. So if the chip throws overcurrent, it will send that pin high, which will then also send the chip into shutdown. It will send itself into shutdown, I guess, or it will tell the amplifier that it's in protection. You know, so that will send that pin high externally rather than coming from the driver card, but it will still trigger the same response from the amplifier. Okay. Well, there's nothing else connected to pin 5, so that's just what I wanted to double check. I want to double check there wasn't any other components on the main board to save us having to remove the driver card, but I think we're just going to have to remove the driver card and see what the issue is going on there. Hako 808. What is that? Let's have a look. Desoldering kit. No, I hate this. No. I've tried desoldering guns in the past and had a terrible experience. That won't help with this kind of board. Trust me, this board, the best desoldering gun in the world would not help with this. I promise you that. Got to wait for this soldering iron to get heat up. Naturally this takes a little while to heat up because it's massive. Someone still says R132. So R132 we tested earlier was fine. R132 does read fine. Unless it's died in the meantime, but we did test it at the start of the stream. What do we have? We have 1 kilo ohm on this one, and 1 kilo ohm on this one. Yeah, so that's fine. That resistor is absolutely fine. It's not that. We don't have activation signal coming from the drive card by the looks of it. And that's probably because the drive chip, when it died, it might have spiked and sent some stank stuff back to the drive card. Okay. It's not quite up to temperature yet, but I just want to sort of start getting some heat into the board a little bit. I'm going to blast it with the heat gun again before I start attempting to pull these driver cards. Just want to get some solder flowed up on these pins here. You can see I'm flooding it up. I'm getting a massive ball of solder on here, which is going to act as a bit of a buffer for thermal heat and also to spread the heat out. Okay, let's see whether that's enough heat in the board for this to start making its way out. Oh, ow, I need to stop burning myself. Like everything on the board is now very hot. Oh yeah, that's coming out like a freaking ice cream, bruv. Oh yeah, that's coming out smooth and confident. Look at that, almost out already. Oh, don't you love to see it? Ta-da! Fucking boss, mate. Boss skills, mate. So, okay, cool. While the board is still hot, I am going to suck the solder from these holes while there's still some thermal energy in there to make that nice and easy to do. So I can put the board back in, and then see this. These pins now have like lots of solder on them. So what we ideally would want to do now is take some solder wick, some wick and some flux to suck away all the solder from those pins so that they are just pins and as thin as possible with no solder on them anywhere, so that they go back in the holes cleanly when we go to reassemble it into the board. However, I have run out of solder wick literally a couple of days ago. So I'm going to have to either try and find some other way to do it or just buy some new solder wick and put this to one side until it arrives, because yeah, trying to get the solder off the pins any other way is a bit of a pain in the ass. Old school, I hope your dinner is tasty. Let us know what you had. I want to know. I want to know what everyone had for dinner. Right, we got a lot of different people here from a lot of different cultures, a lot of different countries, backgrounds, etc., different ages. What did y'all have for dinner? If it's not dinner time yet, where in your country, if it's like morning, what did y'all have for breakfast? What did y'all have for lunch? Why am I saying y'all like I'm from America or Texas or something? What did the man dem? What did the man dem have for munch? What was the man dem munching, bruv? I'll start off. I had... Shit, what did I have? I had mac and cheese, but it was like a fancy ass mac and cheese with butternut squash. I think you guys, I think a lot of places will call it pumpkin. It's like, it's from the pumpkin family, butternut squash. Look it up. You make a mac and cheese with that. You whack in some cashews. You whack in some nutmeg. You whack in some onions and garlic, and yeah, it's a freaking tasty ass meal, man. It's like a really nice, thick, pasta-y like mac and cheese. Fucking really, really good. Yeah, man. Damon just ate a cheese sandwich. What, like just cheese? So like bread, butter, cheese, butter, bread, cheese sandwich. To be fair, sometimes simple is best. Actually, I don't mind a cheese sandwich. Made stew with steak. Sounds good, my man. Nice, proper like a red wine kind of like sauce, like a really hearty stew sauce. That sounds good. Just had some smoked ribs, barbecue sauce on that. Barbecue drill, like a kind of sticky kind of what do you call it? Can't remember. Like a glaze. Chinese food, like a Chinese takeaway. Kung Pao chicken, and I'm in Oklahoma. Yo, you're down the road from DD. I wasn't far from you. I visited DD in Oklahoma. Probably would have been down the road from you, my friend. Dinner was fish fingers, mash and beans. Nice. That's like what you'd have as a kid, isn't it? Like fish fingers, mash and beans, like a proper kid's meal. Making barbecue pork chop, sauteed shrimp with veg and spiced rice from Palestine. Cool, man. Sounds cool. Barbecuing it up. Is it barbecue outside? Is it like nice weather, or are you doing that inside? Sauteed shrimp. Sounds tasty. Had some roti and curry. Can't go wrong, man. I love a good curry. I had a curry. I made a curry the other night from scratch. So nice. It had like a kind of, it had some peanut butter in it. It was like a kind of creamy, peanutty, kind of chili, spicy, peanutty kind of curry. It was really, really tasty. So good. I just had sausage and chips. Boring, I know. Yeah, but sometimes the simple stuff just works, man. You're a southern boy, just acting British. Yeah, this is all just a show. I'm actually from down south. Friggin' Dallas way kind of vibes, you know, downtown Dallas. Just bread and jam. Can't go wrong. So basically, this amp repair is taking way longer than it would otherwise because I'm live streaming it. We're 4 hours into the stream right now. And if I wasn't live streaming, I might have been on this, maybe on the second hour, maybe an hour and a half to 2 hours in, maybe something like that. Smoked chicken drumsticks with habanero sauce. Heck yeah, spicy ass. I think that's the spicy sauce. Eating gummy bears. I can't eat too much of the gummy sweets. Like I can have a few of them, really nice, like fruity flavors, but I end up getting a headache. Actually, it gives me a headache after a while if I eat too many of them. All right. So I think we sucked all the solder from these holes, but yeah, we are going to have to, if you don't have any solder wick, what I have found works sometimes is actually load up some chip quick flux onto the pins here, and then you want to get all of the solder off of your iron tip first. This foam thing actually works really well for cleaning off the tip. So to get all that off, and then you can actually go ahead and the solder will want to work its way onto your tip. Sometimes, or maybe not today, maybe not on the day that I decide to live stream it, but my tip's actually very dirty. Actually, it needs a good ass clean. Let's get some green on you. Tip is not clean. Keep your tips clean, gents. Better. So let's see. Oh yeah, it kind of works. Not really how I wanted it to. Yeah, I'm just gonna have to get some. Maybe I've got some laying around the desk here that I can use, like some from the last batch that ran out. Let's see. I do have some here, but it's all used. Whether there's enough free space left on it, I don't know. Put some flux on it. Put some flux on the legs. This is all just in preparation for it going back in the board, by the way. I'm not putting it back in the, oh shit, back in the board yet. Yeah, this is working, even though this solder wick is used. There does seem to be some space still on it for this to work, so that's cool. I mean, it's not taking the solder off as well as fresh wick would, but at least it is taking it off enough, I think, probably to get this card back in the board. Oh shit! I've now soldered the wick to the pin. Get off of there. Okay, I think that one's now all used up. Is there any more on the desk? A little bit more over here. Nice long bit. Should have some space on here somewhere. Yeah, there. Yeah, that should be fine. That's working fine. Solder wick actually has a really high thermal conductivity, so when you're holding the wick with your hand, the heat travels up the wick really fast and it burns your hand. You have to be a bit careful. Okay, is that good enough? Are we mostly away? Yeah, I think most of that solder's away. It should be enough. Should be good enough to go back on the board, probably. We'll see when it comes around to it. But anyway, now that we've removed the card, let's just go ahead and check some of these components that were on the leg, that are connected to that leg of the board. So let's just flip the board over and just remember which way round this was in, so we can figure out what we're doing. That was that way around. Okay, so we are wanting to look at the back side of the board, probably to start with, at least. Back side of the board was connected to there, and that goes like that, and it was that pin there. This second to bottom one, which is going to be this bad boy here, which is going to be this bad boy here. Yep, okay, and I think if I remember rightly that was connected somewhere, some capacitor up here somewhere maybe? Yeah. So this board here is multi-layer as well, and there's lots of vias that go off, so it's very, I don't even think the schematic will show this board. Like it might just have like the board as like a unit kind of thing. Let's just see if we can see what is connected to this pin. Seems to only be that capacitor, but there must be something else connected to it as well. Back one. So I'm going to flip the card over and see what components are on the front here that might be connected to it. Right, I'm just going to see where that via goes. Right. So there's a capacitor here that has continuity, and there's a via that goes up there. Actually, I was trying to do the wrong one there. Here we go. Right, there's a 4. There we go. Right, there's a resistor there. 4221. 4,220 ohms. And on the other side of that, there is, what are you connected to on the other side? R130. Anything else? A bunch of other stuff. Okay. It's going to be a bit tricky because really I want to be able to probe all of this stuff while the board is powered up. Like I want to have the board running and be able to kind of like probe this stuff and figure out, right, where's the shutdown voltage coming from, kind of thing, you know. But what I'm going to do is just a clean sweep. I'm just going to do a clean sweep of the board and see whether I can find any transistors that are shorted. Ah, here we go. What's this? Q30? Are you supposed to be shorted? Possibly not. Okay, Q30 up here has a short between legs 1 and 2. Fucking camera for the multimeter is glitching up again. Let's get that sorted out. So yeah, Q30 has a short between 1 and 2, or 1 and 3, whatever pin that is, but the top and bottom left than the top. So let's just remember that for a minute. Remember that that's there. Going elsewhere on the board, looking for shorts. Like when these transistors fail, they will often go short. So it's a good idea. It's a good thing to do, just as a kind of like initial thing, just to go ahead and check. You might end up finding the fault really quickly by doing this, because resistors will usually show visual signs of failure when they go. Capacitors, these little SMD capacitors, don't usually fail really. It's going to be the semiconductor parts that are the most sensitive to failure. So transistors, diodes, ICs, that kind of thing. So the first thing I want to do is check with these resistors. Now, especially if any of these resistors are connected through to this trace in any way, shape or form. Which I don't think they are, but okay, Q30. So let's go ahead and check one of the other boards that's still in the main board. Let's see if I can read Q30 on one of these boards. On one of these boards that's still in the PCB, and see whether that's supposed to be shorted or not. I hope that it's not, because that will mean that I found something that was wrong. Right, Q30, where are you, Q30? You're way over here. There you are. Oh, for fuck's sakes! It's by design. It's meant to have a short there. Okay. Okay, visual inspection. Let's have a look. Can we see any bad resistors or anything wrong on here? Because of how easy this driver card was to come out the board, I think I might end up just swapping out one of the known working ones and put it in the bad channel, just to confirm that there's nothing else wrong on the board for that channel, and that the issue is actually on the drive card. Just looking for surface mount resistors that have like black marks on them or something to show that, you know, they might be failed. Let's just check this resistor right here, R23. It's a 4221, so we're looking for about 4220 ohms. Yeah, 421k. That's fine. What about this one? This one is a 3321. That's correct. Right, where does that go next? here, maybe to these transistors down here perhaps. Flip her over. Q10. Is Q10 supposed to have a short between those legs? I imagine it probably will, like, it seems to be the theme going on here. Q10. Yeah, by design. Q23 also has that, but I'm guessing that's probably by design at this point. Okay. Right, there's two ways I can go from here, okay? There's two things I can do, and I'm interested to see what you guys think. Those that are actually following the repair, not just here for the vibes, right? So we have driver card here in my hand with potentially a problem somewhere in it activating the drive IC, you know, telling it to become active and not being shut down anymore. So we have good working channels on the board. We have examples of good working channels. So what I can do is I can swap one of the driver cards from the known working channel into this location, just to see whether that makes this channel come to life and work. Just as a proof that the channel is fine and it's the driver card that's the issue. So we can do that and just see what happens. Or I can take some of these headers, some of these cables here, and I can fit them into the board here. I can solder them all in and mount the driver card onto the other end, which will allow us to power the amplifier up with the driver card out and start probing around and see where the shutdown activation signal is supposed to originate from and why it's not originating, why it's not coming out of there. I think this will be more of a pain in the arse, personally. It would take a little while to do that, like to solder each one of these in, then work out which colour is supposed to go on where, etc, etc. If we do flip one of these out, if we take one of these cards out, I can quickly do some like comparisons, perhaps, out of the circuit before I drop it back in. What do I reckon? Swap the driver card, El Fuego. Sure, swap it, but I think you should put headers in there. I don't really trust headers. I'm not a huge fan of headers personally. Although that might be a good shout actually, because if I put headers in and yeah, maybe headers is the right thing. Yeah, maybe headers is the right way to go. And do I have any headers that are going to be any good for this? Most of the headers that I've got, I don't really know if I trust these headers to be good. So I'm just checking the headers that I've got. There's not much leg on these, and the headers they just kind of like, the headers I've got, they just kind of fall out. I don't trust that they're going to make a decent connection. I risk damaging more stuff, I think. These ones seem good. Actually, I think I've got a few different types of headers. Maybe I'll go for these smaller ones. Yeah. I've got a couple of different types of headers. So I'll just look for these smaller ones, and I'll just use these. Arduino breadboard cables would be great for being able to run it remotely. Yeah. Okay, well the first thing we're going to do is I'm going to put one of the driver cards from the good channel into this channel and re-solder the drive IC and just see what happens. That's what I'm going to do now. Why would you choose headers over the ribbon cable? Because the headers I can just literally swap, like plonk it in, take it out, plonk it in, take it out. With the ribbon cables, they're not going to be like organized in the right orientation. I'm going to have to like make sure that I've got the right color wire in each of the right pins every time I take the card out and put the card in. So. This iron is nice and toasty now. It's been cooking away while we've been chatting just now. Didn't turn it off from earlier, so it's nice and spicy. One half walked out. Another half walked out. And just got to keep doing it backwards and forwards until the whole thing comes free. Cool. Right, so that's the good working card. I should probably mark them so I know which one's which. Bleep. Hello from Oak Ridge, Tennessee, my friend. How's it going, man? Wow, long way away. Hope you're good. Hope you're having a good day. What is it? Damn it, this solder flux already, this solder wick already be all used up, y'all. Not ideal. I rarely use solder wick, and I used some a few days ago. Got to the end of my reel and thought, yeah, I'll order some some point. Don't really ever use it, so but the next amp that I work on, end up needing it. It's just the way it goes. Even though this stuff is used, it still appears to be working, still doing the job. It's not fully taking the solder all the way off, but it's probably taking enough off for it to be able to go in the holes for the card on the board. I hope. Okay, let's give that a go. Let's see if that goes in. Just gonna check one thing real quick. Over here. And this sticker does not want to stay. Just have to remember that's a good one. I don't think enough of the solder was taken off the legs, you know. It's like peeking. He be peeking. Okay, yeah, kind of through that side. We've got one hole there that wasn't quite sucked. Okay, we're going to have to do what we did earlier, but in reverse. So grab pull it up on the solder and push it through. Oh, it works beautifully in reverse as well. And all of those pads are all soldered in one go. With no bridges either. Fucking awesome. Good old flux doing its job. Right, so now that that's in, we should have, let's make sure I put it the right way around. Yep, all looking good. So now that that's in, I should be able to power this up, and we should have on the what was originally the bad channel, we should have oh, what the heck? We should have PWM on pin 1, which is the input, which was there anyway from the bad card. But we should have pin 3. We should have that going up to activation. We should have some VC, some voltage coming up on pin 3 to take the chip out of shutdown after power up. So let's go ahead and power it up. Just make sure we haven't got any solder bridges on the card that we just removed. No, we don't. Anything from the top board actually worth checking? Any bridges? No, we're good. It's all clean. That's nice. Right, so moment of truth then. This will tell us whether it's the card that's the issue or not. Let's go and get a reference for negative rail. There we go. There we go. Okay, the issue is on the card. It is on here. The issue is on the card because it worked. We got the we got the shutdown signal coming here on pin 3. Let's do that again. Oh, what the heck's going on with your scope screen? There we go. So what we've got here is we're probing channel 1 and channel 2. Channel 2 is tied to negative rail, which is this circuit's ground reference. So when we power the amp up, we'll get a little bump up to about 5 volts above this, or 12 volts above this. There we go. So the chip is now being told to activate, and that wasn't happening with the card that was in the bad channel to begin with. So the issue is on this card somewhere. Where though is the question, because there's no obvious issues on here. This is the point where the schematic would probably be really useful. So I'm going to get the schematic, I think. Maybe this one. This is the... Actually, these are going to be the same between amps, aren't they? Let's have a look. This is the Class D full range power supply clock generator card. No, not that one. That's the power supply. I can probably show you little snippets of this. Oh, here we go. Yeah, this is the schematic for this amplifier. Great stuff. So don't want that page. Don't want that page. Buy a new driver card and be done. Yeah, that would be great if you could buy them. There we go. Right. So here. Just real quick, like you're not going to be able to get to see this, but these are the driver cards, okay? I think. Oh no, that's the crossover card. So it's not that one. To output card. Output card. Front right, front left. Yeah, okay. So this is the schematic for the actual output section on the board that we've been looking at already, and we want this. We want this card. We want a schematic for that card. Do we have a schematic for that card? This is the output card, 1405. Are we going to have it? No. The schematic doesn't come with a circuit diagram for the fucking output driver card by the looks of it. Rear right, inputs, This is the input section, the RCAs. That's not what we want. This is the power supply clock generator card. I think this is just the power supply card. Don't think this is the output one. Although it might be. What is the code on this? 104554. Wait a minute, let's have a look. This is one of the output channels. So we want driver card 1405 54131. 54130. No, so this is not correct. This is not the one that we want. Nope. We don't have it. We don't have a schematic for the drive cards on the output section. Okay. So, quickest way to diagnose this then. What's going to be the best way to do this? So, we know that the shutdown signal and the enable signal comes in and sits on, where was it? Here we go. We got two resistors over here, okay? It comes in here. That's where it goes out to the main board. Okay, so what does this resistor connect to? On the other side of this resistor, we have a connection to R130, okay? We also have a connection to this resistor down here, which is R117. And is that it? We also have a connection to this capacitor. Anywhere else on the board? Maybe the other side as well. This is going to be so fucking hard because this is double-sided. So, oh, something down here. Here we go. R89. So what I'm going to do is this capacitor as well. So what I'm going to do is I think I'm going to go off on each of these trails from each of these components that it's connected to and see if I get to any dead ends. Right, so I'm going to start off at R89. I just like that way, that path. So on the other side of R89, and we also have C53 and C51, fuck's sake. So on the other side of R89, what do we have? Continuity 2. Anything around here? Here we go. D7. And also Q20. Okay. Q20. So this is where I'm going to stop at this path. I'm just going to check Q20, see if it looks like it's okay or bad. There's readings of what I expect to see, to be honest. Nothing untoward there. And D7, do we have a diode that's shorted or anything? We've got 670 one way round, other way round, is it leaking? No, that's probably fine. Okay, so let's go instead down the route of this one here, R130. Other side of R130, I'm just going to check for continuity to any of the board legs, in case it's ground or something. Nope. So where do we go for R130? We go up here and we go on to the other side of the board, which I'm going to have to check out in a minute. Do we have continuity to any of these around here? Maybe. Nope. It goes to the other side of the board, so I'm going to have to try and keep my multimeter on there. Go to the other side of the board and have a look for continuity over this side. It goes up there and goes in here maybe. Okay, Q36. We have continuity to Q36. That seems to be it. So let's go have a look at Q36. Any untoward readings on Q36? High values this way round, so we should have low values this way round. Oh, hold on a minute. Oh, hang on, that's Q37. My bad. Shit, hang on. Right, Q36. Q36 seems to be okay. Q37 was giving me some interesting readings though, one way round. Q37, high values one way round. I got a 585 that way around. Okay, that seems fine. So, fucking hell, man. Fucking hell, man. I'm a little bit bamboozled as to where to go from here, because this is a completely bespoke circuit. I've not seen this before. Without a schematic, I don't really know. Like the signal for shutdown and activate, it goes off on so many different branches on this driver card. The driver card is double-sided, making it very difficult to kind of follow traces and stuff like that. There's nothing visual on here that like. There's no like resistor that's kind of burned out. I can't see any transistors that are shorted or anything like that. It might be the case that one of these op amps has failed or something like that. We're just gonna have to start blindly replacing components until something changes. I can put this board into headers, into these test patch leads here, and we can get the board up and running off of the PCB, okay, and then probe while we're powered up to see if we can see where the signal's coming from for operation. But again, I don't really know where it's supposed to be coming from, so because it's not present, doesn't really help me. Obviously I can use one of these ones that's working. Like I have many channels here that are working fine. And I could possibly, because I don't really want to have two boards on headers, it's just a lot of work to put both boards in headers and remove them and stuff. So it's possible that I can, with this board out of the PCB on, by itself down here, I can be like, right, the signal goes back this way, and then I can maybe probe on the main board without having to remove any of these boards like this. I get relatively good access to this PCB here. Actually, I get great access to this one. I get good access to this board on this side. Actually, I've got pretty good access now that one of these boards is removed. I've got pretty good access to get my probe in here and start probing around while the board's active on these ones. So, yeah, okay. I think the sensible thing maybe then to do is to whack in some headers here, some patch leads here, get this up and running out of the board so we can probe it on the bench. Jeremy says I would measure resistance on each component and test one working and one non-working. It's going to take a long time. There's going to be hundreds of components on here. Yeah, looking for differences there might not necessarily bring us to the solution. What I'm going to do is I'm just going to do one last sweep of semiconductor components. I'm going to look for shorts. Or obviously low resistances. That's when these components die, like semiconductor components die, they'll generally go short or low resistance. So I want to check the op amps as well next. I wanted to see if we've got any shorts on any of the op amps over here, between any of the legs of the op amps, just anything obvious. Sometimes I just get lucky and find like a short or something by doing this. Well, I hope this is entertaining for you guys anyway. If you're noticing any like low resistances on the screen, give me a shout. Like I'm listening for beeps really. We've got some shit under this sticker here. Let's remove this sticker. a sweep. Let's do a sweep of transistors and diodes left to right. Just as a quick check. Just looking for any shorts. Q30, I think we decided that one was supposed to be shorted between 1 and 1. You seem to get 1 and 3 connected on a lot of these transistors just by design. R89, what are you? What are you, R89? 865, and is that the same on a functioning example? 865. Yes, it is the same. What about you, R117, because you are part of this circuit that we are dealing with. You are 21K. What about on a working example? Oh, hang on a minute. Okay. Well, that's different. Okay, okay. It's climbing. On a working example, we have 8 points. Well, it's climbing, but we have climbing to 10K on R117. Whereas on our board here, we have 21K. Okay. You're supposed to be 4993. You're a very, very high value resistor. So the chances are that when we're reading the resistances across it, we're actually reading like other paralleled components on the board. But the fact that there's a difference there is interesting. So okay, it could just be because the board that I was reading here is actually mounted in the PCB, which could also change the resistance on that resistor because it's reading parallel stuff on the board. So okay. You know what? Let's whack it in headers. Let's whack it in headers. Bevins, it's okay if you toss the damn thing aside. We won't question abilities. No, see, I'm not a quitter when it comes to this. So I know this is taking a long time, but I am also streaming, which makes it take a lot longer because I'm kind of talking through what I'm doing, working out the cameras and stuff like that, and I'll also take breaks to chat to you guys. If I was working on this myself, just without streaming, I would possibly be on the 2.5 hour mark, which for this amplifier, this is a very expensive amplifier, is fine. It's not got to the point yet where it's not worth the repair. The fault with this amp is going to be one tiny pissing little component. It's going to be one fucking tiny little transistor, small op amp or something. It's going to be a low cost on parts repair. It's just high expense on time, and because I'm streaming this, it's good content. This is an interesting repair. It's not just normal bullshit, FETs, drivers, gates, etc. So I am more than happy to continue with this and get to the bottom of the fault, because who knows, one day someone with one of these amps might have the similar issue, and then they've got the solution without having to go through the painstaking process that I did to get there. Oh hey, someone in the live chat just said FLIR, as in thermal imaging camera. brand. That's not a bad idea actually. If I get the headers in this, I could actually power this up and see if there's any hotspots on the driver card, because when components fail, they can often get a bit toasty because they're leaking or something like that. So yeah, I'm going to get the thermal imaging camera out once I get this sheet sorted in the board on its headers and stuff, and that might be interesting actually to see. Might make this a part 2 though, because it's getting kind of late here in the UK. It's now 1:45 in the morning, so when it gets to 1, I'm going to lock off the stream, regardless of whether we've repaired it or not. And yeah, if we haven't managed to repair it, then I'll continue with this different day. Make a part 2. Get to the bottom of what this is doing. Be interesting. Right, so let's work out what colours we are putting in here then, shall we? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 on one side. You know what I might actually do? Something that might make my life a lot easier actually right now is just to get these in the right shape and like tape them together, maybe? Tape them into the correct shape. That might be a cool thing that's worth doing. I guess the closest thing I've got is some Tessa tape. That's not late, it's Saturday, Sam, you're still young. Yeah, it is true, but I don't want to get into the habit of like late nights, and my girlfriend is probably wanting to go to bed soon as well anyway, and don't really want to be crawling into bed at like 3 AM waking her up. So yeah, we'll lock off the stream at 1. I think that's a good place to lock it off, and if need be we'll continue this another time. Yeah, that's cool. Just tape that into shape. So we now have the correct shape on that. So all I need to do now is just I need to mimic the shape on the other side so that the pins go in the right freaking holes, because that'd be the worst thing, is putting the driver card in and the wrong pins are in the wrong places. So if we can mimic this on the other side, so we got, if I mash all these together like I did just down there, and then see which ones are wrong. So okay, where are we? Okay, so we have orange, yellow, that's correct. Green, blue, yes. Then we have grey, what looks like a kind of dark purple. See, these are all mixed up on this side. So these 4 are correct. These ones are all mixed up. So we have this kind of dark purple, needs to be there. And then on the other side of that, we have this kind of dark grey. So dark purple and dark grey go together. And then we have white and black. Okay. This is actually possibly going to be quicker than I thought, just because of this method that I'm using here. Okay, cool. That is now perfect. So I just need to get some tape. Like me personally, if I had a coffee right now, if I grabbed myself a coffee, I could probably go on till like 4 or 5 AM. Like this shit is interesting for me. I love this shit. I love this troubleshooting with a new circuit that I'm not necessarily so used to. It is interesting for me. I would definitely be fine with like staying and getting this thing sorted into the early hours of the morning, but I know that I'd probably regret it the next day. I'd feel like shit, you know. So fucking tired as fuck, man. Right, there we go. So white, black, purple, green, orange on that side, yellow, blue. Yeah, perfect. All right, that is bank number 1. We'll drop that into the board. He says, come on. Oh shit, you know what? I didn't use enough pins. It's 5 per side, not 4 per side. Oh, what a dickhead. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll tell you what's wrong with that amp if you don't answer your landline phone. Oh, bruv. Well, you know what? I do have a landline phone, you know. I do have a landline phone, bruv, you know. Man's got a landline phone. I like that people still remember that reference. That's good. That's good times. Genuine question though. Who here actually still has a landline phone? Like, do people still bother? Like, I don't actually have a landline phone here. The new place. Like, I never. There's no point. I don't have a need for a landline phone these days. You know. Then we're still bother with landline phones these days. Rob still has one. Rob still has a landline phone. 25 hertz, no landline. It's old school. Yeah, I bet Big D Wiz still has a landline phone. He's old school. I bet he calls Kicker up on his landline phone. Right. What do we got this time then, fool? We got green, orange, brown, white, purple. Green or orange, brown, white, purple on this side of the road. Green, orange, brown, white, purple, and then on the other side. But I can tell that it's getting late. I can tell I'm getting tired because I'm making stupid mistakes like this where I screwed up by not putting enough pins in this other one. So like soon it will be not ideal for me to continue. Blue, yellow, red, black, grey. Cool. We are good that side as well. And thanks for the 10, Rob. Sorry, I just missed that. Thank you so much for the 10, my dude. Really appreciate that. Giving me strength to carry on, bro. Big D still has a Nokia 3310. Oh, it wouldn't surprise me. Wouldn't surprise me if he still has one kicking around. 13 BDRX63, how's it going, my man? Good to see you on the stream. You got a fax as well. Kevin's got a fax still. Fuck, man. Can you fax me a biscuit? Man would love a biscuit. Right. Let's shove this in here. I know you want to go in. Oh, they're slightly too wide. I'm going to have to bend them in. Right. So I was putting it in from the bottom just to kind of get the pins lined up. Give it a wiggle so that they stay in place. Then I can put it in from the top. And they should be in the right position. Should just smoothly drop in. Maybe not. It might have just been quicker to put these actually, you know what it would have been better to do, just put these in one by one at the bottom and then like tape them up at the top. I thought I'd be clever by doing this, but maybe not. Because it's a pain in the ass to get them in, because they're all in a block and they move around lots because they're just kind of like taped together. Yeah, this is the most bullshit thing. Fucking hell, man. This is the most bullshit thing. Maybe I can just go in upside down and work out. I don't know. Fucking go in, man. It's almost there. It's almost there. I can feel it. Right, what one's missing? Pin 4 on top. Get tweezers. Get in there. Alright, there we go. All the pins are in the holes. There we go. Yeah, boy. Let's get those soldered in before they move out. This is one of them complex issues, man. This is one of them complex as ass issues. No, like, honestly, wasn't expecting this. I was expecting some drive circuit faults, but I wasn't expecting a shutdown activation enable fault either. Like, this is bullshit, man. Right, what we got now? Where's that other one that I did earlier? Here we go. I need 2 extra on this one. So go for over here. What one's missing? It's always that second one that's not going in. Come on, you bastard, go in. You are too far to the left, I see, okay. Cool. Right, that is my phone telling me that it's 1 AM. So I think we'll call it in a minute. We'll get these in and we'll call it for tonight, I think. And then continue with it another day. but I do want to try and just get this powered up off the board first. So maybe we'll go to 115 or something like that. Oh, fucking hell, come on, man. Fucking go in. There we go. Right, and then I need two. I just need two more because I screwed up the first one. Two more up there. Yeah, that'll do. Red and white. Man's hungry. Man is hungry, bruv. Okay. So we're all good. We have patch wires soldered in. So now we just need to make sure that this goes in correctly, correct way around, etc. So we have 1, 2, 3, 4 like this. Oh fuck, you know what? You know what it is? These legs aren't even long enough to make a contact with the fucking pins inside here. Nope, they're not long enough to make a contact to the pins inside. I could make them long enough by cutting off this plastic spacers, but that would be ruining it. That would be bullshitting it. For fuck's sake. This is also why I didn't put headers in, because the legs aren't long enough. I don't want to pull the plastic off the board pins, really, because this is a nice amplifier, and that is a irreversible thing to do. Like, it's fine. There's nothing wrong with pulling off these plastic spacers, but it's an irreversible thing. Like, yes, it would be a nice quick thing to do. I could just quickly do that, and it would be done, and then they'd go in the headers. But it is irreversible, and as you know, a tech and as a repair tech for the customer, that's not really what I want to be doing. It's a bit janky, you know. maybe I could heat them up a bit so that they come off, and I can slide them back on afterwards maybe. But yeah, I think this is a job for another day, guys. I think it's a job for another day. One thing that I do want to do though, just real quick, just before we go, is I just want to confirm that the original channel that failed, this one here, is now fully functional with the donor driver card from the originally working channel. Yeah? So just real quick, just before we go, I'm just going to confirm that this channel that was originally dead now works with the working driver card. And then we're just going to take a quick look online and see if we can find these drivers anywhere anyway, because if we can't, then there's no point really going much any further with this, because we need the drive transistors, sorry, we need the drive ICs. We need at least one, because we have at least one that's dead anyway, you know? We have at least one dead drive IC. So, okay, I'm just going to solder these the drive IC back onto here, the one that was originally from the good side, just to confirm that this channel now works. Bit more flux. Driver from the good channel. Bit more mass heat. Okay, cool. Let's just check that that's soldered down correctly. All pins soldered. Yeah, looks good. Let it cool down for a minute. Right, that's cool enough to power up. So yeah, we're looking for switching on low side drain. Hopefully we haven't killed the drive IC by removing it and fitting it a couple of times from the heat. So okay, let's go. Low side drain. What are we saying? Hey, my boy! Excellent stuff. So the channel that originally came in dead is now working. So we have confirmed then just by doing that the issue is it is on the driver card. It is on the kind of whatever the fuck I've done with it. This thing here. The issue is on here, and we have PWM coming out of here into pin 1, which is the input pin of the drive chip, but we don't have the enable signal. This card supplies the drive IC with the signal to go to say, hey, start working now please. That's not coming from this, and it is remaining in shutdown mode because it is the enable signal is just at ground for some reason. So yeah, I guess we will dive into this a bit more another day. Maybe not tomorrow, Sunday, might be chilling. Maybe Monday perhaps, maybe Tuesday, maybe a day next week. We'll dive into this a bit further, and then once we have repaired this and finished with it, we will look at the smaller version of this amp, which is the 800, the 800-4. Just before we go though, don't go anywhere. I'm just going to take a quick look to see whether we can find these drive ICs for sale anywhere, because like I say, if we can't, or if we can't find any suitable replacement, then there's not really much point going much further other than just for entertainment purposes. So let's just go ahead to some websites that I might order parts from, just to see whether they have any in stock. I know that they're end of line, but just out of interest, see if they have any available anywhere that I would buy from. Nothing. Ah, okay. Whoa! So Farnell, I'm able to get them, but I would need to request a quote minimum £500. Large Components doesn't have them. Fuck. I don't ever recommend going on eBay for parts, but with these drive ICs, you're less likely to get fakes, I think, because they're so bespoke kind of thing. You know, they're so specific, so it'd be really hard to kind of rebrand or fake that one. You know, China, it's going to take months to arrive. Is there any in the UK? If you're buying from the UK, be prepared to get bent over hard. £15, man, for one of these things. It's like 20 bucks. Cheapest is $8.99 for one of these bad boys. Will likely be genuine though. So at the end of the day, if it's if it's £10, if it's 10 or probably like $13-14, if it's $14 to get this amp fixed, once we find the fault on the driver card, then so be it. The cost is passed on to the customer, but I really don't want to fucking pay that much money for one chip, bruv. What, you know? So this is a half bridge driver, right? This all drives the screen here. We have 1, 2, 3, 4, 5, 6, 7. We have 14 pins. Bootstrap high side. Operates up to 1 megahertz. Logic level 200 volts. So what we can do is we can actually try and find a part that might actually replace it. You know, that might actually work in its place. Let's just to try to get the category right. Let's just go IRS 21844. It's only because I know that also takes a single input. Gate drivers. So power management, gate drivers. Gate drivers, and we want to go. What package is this again? Should tell me here. High and low side, MOSFET 14 pins, SOIC 14 pins, supply voltage 10 to 18 volts. Okay, let's see if we can find something then that will work. Pin count 14. Package type SOIC. Number of outputs, I guess it would be 2. High side, low side. Topology, half bridge, high and low. That's the same thing pretty much. Time delay, whoa. Bridge type. It's going to be a half bridge, but it's 14 anyway. Logic type, brand, output current. What's the output current of this? Does it say? Doesn't really say in the specs here. It's probably not that important right now anyway. Supply voltage. Oh shit. Okay, I think I've got 12 volt supply on this board. Maybe that's the maximum supply voltage that it's quoting. Okay, I'm just going to apply filters and see what we get. 27714. What's this? I'm looking for something with a similar model number, just in case there's like a new version of it. We've got an IR 21834. There's bound to be one of these that work. It's probably not going to be an IR prefix part, because an FAN. Oh, okay. Okay. Let's start looking at. Let's just try and get the output current of this one. I think I've got the data sheet already up anyway. But what's the output current of this thing? VA watts. Maximum power dissipation 1.25. So let's just look at maximum power dissipation real quick and see. Do we have power dissipation? No. As a thing. Okay. Well, let's just take a quick look at this chip. Let's just see what the pin out of this chip is. Okay. Well, that's not available anyway, so let's forget that one. How about this one? Not available. Fucking semiconductor shortage is not doing me a favour. That's the same part. I don't really want to have to buy 55 of them. Okay, they're in stock. What do we have on the pinout? What do we have on the data sheet? What is the pinout? Because that's the first thing we want to look at. What's the pinout? Okay, this takes high and low side inputs, so that's not going to work. Let's close that one. Let's have a look at this one. Not available. Let's have a look at this one. In stock. Data sheet. high and low side input. It's not going to work. Fuck, I think I seem to remember actually having the parts that just have the single input and the chip does the high-low split itself is really uncommon. High and low input, no good. I'm probably doubling up. I've probably looked at some of these already. Low in, high in, I'm good. Okay, what about this FAN? FAN. Not in stock. I think I looked at that one already. Not in stock anyway. Yeah, this is just fucking not good. Looks like we're gonna have to go with the eBay chip if we're gonna need a chip. You know, in the day we're gonna need a chip. So I'll do some more research in my spare time, but it looks like I might have to go with the chip. Let's have a look at what you guys are saying. Oh shit, some donations. My guys, what are you doing? 13 BTRX3. My man, thanks fucking hell for the 20. That's a lot. For that never give up mentality. Appreciate that, man. I am a trooper. I will get this thing fixed. I don't care. So let's have a quick look at what you guys are suggesting real quick. Pop the connectors out the housing. I got some saving some rest. Yeah, definitely need some rest. Bro, take a working board out of that signal. Inject some signal. Can't really inject some signal out the board because I need all the supply voltages and there's so many of them. Split the wires or solder the wires to the doors of board. Messy, but okay for testing. It's just long. Please can you do me a favour? Can you go to your video called Room Setup and Plans for the Situation? The songs I was playing on piano are... If you're young, moving upside around you, Hold Ya is one of them. There's another garage song that's like Summer Jam, I think it's called, is one of them. The other one is called Show Me Love. And thanks for the $9.99, Mike Honda, for the $9.99. Thank you very much, my man. Really appreciate it. Yeah, I don't give up, man. I don't give up. Jamaica in the house. What's going on, man? Love to see it. Love to see it. Is there a way to bypass the Tarrant PIC chip? No, but you can bypass some of its protection modes and such. I guess you could actually bypass the Tarrant PIC chip. Yes, you could fit like a TL494 and run the power supply manually like that, and then. Although I think the Tarrant PIC it generates a clock cycle for the output section, so you'd have to also have something that generates a clock cycle for the output section. Oh, hang on a minute. IR21844S, isn't that the same? Doesn't that have this? No, the RS21844S doesn't have overcurrent protection on on pin 5, so that's not going to work. But it is similar in the way that the RS21844S has pin 1 as a single input for PWM, and I think the outputs might even be in the same place. Actually, you know what? That is a very similar pin out. RS21844S. That is actually a very similar pin out, you know. Scroll down here. Nah, actually, it's a lot different. Actually, well, once you actually look into it, it's a lot different. Yeah, it's loads different. Yeah, 5-hour stream. My bad. I'm tired. Right, cool guys, thanks for joining. I'm going to get some sleep. It's been a pleasure, and we'll continue with this next time. Peace out, have a great day, have a great evening, stay safe, never give up, never stop learning, never stop trying. Peace out. See you next time.